Welcome back to the stream, folks. We're going to do something substantially similar to yesterday's stream. And this will be just another kind of chill software co-working stream on this Rust project. And this will be in some relatively low-level Rust code. This project is a little bit full stack, I think, as they say. It has stuff going all the way from kind of application level HTTP sort of stuff all the way down, in this case, to stuff around the kernel to user space interface level. So kind of dealing with raw system calls and memory mappings and stuff like that. And specifically, we're getting more into how I'm dealing with memory allocation in that particular low-level context. The short story is that I've been trying to avoid it, and I think there are a couple things that are necessitating it at this point, but I'm still going to try to limit how much I use dynamic allocation and how I use it. And we've just got to actually implement it. So, like, there is no allocator, so, even if I wanted something fancy, I would have to choose it and then figure out how to wire it up in this particular case. Do we have cat cam? We do. This is the star of the show, Tuco. He currently can't get enough of this cat food that comes in these ridiculous little plastic containers. And he makes a giant mess and gets it all over the floor. And I just cleaned it up, and he's already made another mess. But he's a cat, so, Looks like we are live on the usual spots. We've got the YouTube channel over at scanlime-in-progress on YouTube. And there's twitch.tv/scanlime. And you can always use the chat or the notification on either of those platforms, but I've also got a little Twitter bot for folks who are always on Twitter at Scanlime Live. And you can always get the video bits directly from the source if you go to live.diode.zone/scanlime. That one currently does not have a chat platform associated with it, but you can at least get a video stream, which is something. Yay, technology expectations. So yeah, I don't know how much energy I have. I feel like I barely got any sleep last night, and I did a long stream yesterday, but I've got some coffee, so there's at least something. Split screen action. So yeah, for folks who haven't seen it, this is the project that I've been working on recently. It's Tuco keeps going back and forth between these two spots. I might just have to set up some kind of better camera over here. And of course, as soon as I start to move the camera, Tuco wanders the other direction. That's fine. He's also been asking me over and over to open the door and close the door. Like, he likes how exciting it is outside, but I don't think he likes the cold. So yeah, I've gone into some of the background on this project a bit more in the other streams. I don't know if I want to get too repetitive, but the short story is that as part of a broader effort to try to build tools for doing decentralized video, I found myself wanting a tiny and easy to deploy low privilege container framework for Rust. And so that's what I am building here. It's a thing that's designed to be easy to stick inside of other network applications in Rust that are already running inside of containers or various other sort of low privilege Linux environments. But then within that, you want to be able to spin up a quick disposable compute container that you can use for transcoding video. So that's pretty much what this is for. Right? That's what always comes up. If only there was some kind of robot that could follow Tuco, some sort of flyer perhaps. Right? I was thinking that this new place I moved into this year, or late last year, early this year, has been it's maybe too small for the flyer, because the previous place I was in was kind of huge, big ceilings. But the flyer could honestly handle this thing, just moving a camera back and forth between the couple of spots that Tuco likes to hang out in this room. So yeah, maybe I can just adapt the same old flyer to work in this room. I've just got a much better idea in general of how things are set up now than I did earlier in this year. There are so many dependencies involved in just getting this studio set up, really. Oh, is the camera focusing on something completely different? Yeah, I have it cropped weird. So, of course, the autofocus is seeing parts of the frame that aren't actually on the screen right now. He wants me to open the door, and then he's going to leave. I guess he's going to leave even if I don't open the door. False perception of causality there. He's just headed back to the warm spot, regardless. Oh, Tuco. Yeah, he does have great ears. He is such an ear cat, too. He loves it when you pet his ears. Gosh. I'm going to have to stop cropping this weird as long as there's such a light difference in the shot. Hi, Tuco. Are we adjusting the layout in real time? Oh, he found a catnip toy over there. I don't remember bringing that over there. I think a couple of those toys are mine, but like I think that was one that he found. Is he eating the catnip, or did he find some food in that same general area? I should probably have a crop filter set up so that I can get the middle of this in portrait. Oh, I kind of already have that. I have a square crop filter already. Let's just use this. Because, like, yeah, all the camera stuff is center weighted, so I should at least be cropping from the middle. Oh. Mr. Writer is wondering how Tuco reacts to catnip in general. He seems to be pretty into it. Like, he seems to have a fairly typical reaction for a cat that likes catnip. Like, you know, he gets kind of like extra scratchy and playful, and, you know, he like bites at it and he eats it sometimes. When someone's asking what the chat calls me, I mean, I think that's up to you, but like, my name's Micah and my handle is usually scanlime and my pronouns are she, her, so like any of those are fine. Yeah, maybe I should give Tuco some catnip. He probably would be into it, and I think I saw some recently. If he was going after that toy, he probably wants some, and the catnip in that toy is kind of stale. I don't quite know how it works for cats. Like, I don't know, it's just like the smell activates some kind of response in cats, so maybe if it's been out for a while and the smell is mostly kind of evaporated, then that doesn't work. I thought I saw some catnip in here. Maybe Tuco found it before I did. Oh, here it is. Tuco definitely moved it. Yeah, maybe he's been trying to open this jar. Tuco, is this one? Is this something you're after? Do you want this? Let's make Tuco bigger. I mean, not IRL, but... Oh, no. No, I don't want the crop filter. Oh yeah, Tuco's just following me now, looking for the catnip. Tuco, is this the thing that you want? Are you appreciating my ergonomic workspace? Hmm. Do you want me to refill your toy mouse, honey? Oh yeah, some of this smells pretty strong. Oh, honey. Oh no. Well, here, you can finish making a mess with this now. Right after I finish cleaning up all the meat mess that he made from his breakfast. Maybe I can just hang out nearby. Gosh, so on the last stream I was going over a bit more of the like higher level little miniature victories, like things that actually work in this little container runtime, this little sandbox. And so there's some things that work. Like I spent a lot of time just getting basic things like command line arguments and environment variables and standard I/O working, but those things mostly work now. Yeah, cats are great at making messes, that is for sure. Oh, what is that in chat? Can I live translate Arabic? Wow, that makes no sense through the auto-translate. I can't tell if that's like religious or spam or harmless. Tuko, are you done? He's very soft. I'm glad he's eating better. Like, he's super picky about food, and so I've had to keep kind of trying different foods to find something that he'll reliably eat. And so he seems to really like this stuff, although he still has some weird eating patterns. Like, he'll go right after the gravy on the meat, and he'll be kind of reticent about eating the actual chunks of meat, and he'll do it eventually, but only if I am kind of insistent about not just giving him more gravy right away. Oh yeah, Tuco's really seeming to... So he likes licking this toy when he's on the catnip. He just gets like soaked with cat saliva. But yeah, I'm glad he's eating a little better. He was kind of a little overly skinny before I found some different cat food for him. I haven't weighed him recently, but it seems like he's a pretty good size. So on the last stream, I was getting kind of frustrated that there was no apparent way to do just like a sensible, very special purpose kind of allocator, like something that you could use to allocate a boxed value, but without registering it as a global allocator. I made something that kind of works by just mapping a chunk of anonymous memory and then Oh, hey Tuco, you're moving your head on me now. Aw. It just does a mmap for each of these like fairly coarse-grained, like per process kind of allocations that I've got. And then, uses a little bit of Rust unsafe code to just stick my new value in there. But that does involve moving the value. So I don't think that's going to work for values that are so large that I can't reliably keep them on the stack even during construction. So yeah, I'm still trying to figure out where the boundaries are between different kinds of allocations in this system. My strategy has been mostly to keep things as static as possible. Like my kind of platonic ideal of a computer program is something where all the addresses for all the possible objects that you could want are calculatable at compile time, and we just use the virtual memory subsystem as it was intended. But that's often not possible, and it's almost always impractical. So I'm kind of close to that in the current code that's checked in, but instead of actually constructing these values somewhere where the addresses can be known at compile time, I'm kind of getting stuck with putting them on the stack because of what I understand to be a limitation in representing async closure types, or just closure types in general in Rust, that you can't write the type associated with a closure like in your source. So any place where you have to be able to actually write the type of a closure or of something, like in order to make a const, for example, you have to be able to write the type. So you can't, I understand it, have a const closure, like any const value that contains a type of a closure for that reason. So my current solution was to just sort of have one giant object that I stick everything in on the stack, but that only really works up until I start hitting the stack limit. And you can try to improve the stack or increase the stack limit up to a point, but ultimately you're subject to the U limit in the kernel. And for compatibility and portability reasons, I would really rather not rely on the kernel's notion of what the stack or the heap are when I could just mmap a block of memory and always be able to get a block of memory from the kernel that way. So I'm already using, like, mmap is a nice building block to rely on, whereas things get a little more complicated if I start trying to use things like break or like an entire libc at this level. Go. Are you done with this? Should I clean up this mess so that I can sit down? I'm going to put his toy over here and then just like sweep up the catnip mess. Oh, sorry, Took. So, my ideal here is that I don't need dynamic allocation really, but like, okay, why not? Why wouldn't I just use the standard Rust allocator? I mean, the standard Rust allocator requires the Rust standard library, or it's part of the Rust standard library, which I'm not using in this particular piece of code because the Rust standard library depends on the system C standard library, which I'm also not using. And the reason I'm not using that is that it's mostly an issue of keeping the build dependencies and the build process for this as simple as possible. If I was using a libc at this level, I would need to be able to still have very tight control over what system calls that libc invokes, which is possible to do, but it now means that, like, if I want to support applications that are built against, say, both like the muscle libc and glibc, now I need to deal with the sort of totally different system call profiles that I might see from running the same program under different libcs. Like, the thing that I'm actually trying to interact with here is that system call layer, so it actually seems to simplify things in most places. Like, where it actually really needs to be simplified, it seems like I can simplify things by dealing with the system calls directly pretty uniformly, rather than relying on some libc that I don't necessarily have full control over at this level. But that means that some things are inconvenient, so like I have to do I/O at kind of a low level. Like I was using printline on the last stream, and folks were talking about printline, but like that wasn't even the standard printline. That was just like my own printline macro that I wrote to have the same signature. So, and like dependencies in general aren't really a problem here. I do have several libraries I'm using that are designed to work with Rust no standard. So it's actually pretty cool that there is kind of a growing standardization effort around a subset of Rust that doesn't depend on any system libraries, and that's kind of referred to as no standard. And so that's what I'm using for this. I'm using no standard Rust. I'm using just some low-level libraries that give me access to Linux system calls on top of that. And I'm using some basic collection data types that don't rely on dynamic allocation. So some of that's, approaching a higher level, but I think where the fully static ideal really breaks down, now that I've been trying to turn the crank on that process and see like how far does that actually get me, I think the answer is that it gets me up until I want to start thinking about sharing file descriptor tables between processes. Because in my thought experiments for how this data model should work, I think that's where this actually breaks. The thing that I was doing that was kind of marginal already was I just had one big process table where the processes always had address space reserved for them. They would be uninitialized if the process didn't actually exist yet, but we would always reserve some address space for all the processes. This was unwieldy because it was allocated on the stack. I wouldn't ideally want it to be on the stack, but because of other limitations, I was kind of forced to put it on the stack at the moment. And so it was subject to stack probing at initialization time, and it was subject to stack size limits. So yeah, that wasn't so great. I mean, it was not great because it was something that I couldn't implement using these sort of fully static addresses that could exist like in the binaries like read-write data segment or BSS segment. Like ideally, I would have that just linked into the BSS segment. It'd be allocated by the kernel as the binary is loading. It'd be zeroed, or each page would be lazily zeroed as it's needed. So that's kind of the ideal situation. That's easy to do in C. It's currently annoying to do in Rust. Not really in general. I mean, Rust kind of discourages you from static data, but you can certainly do this in Rust. Like you can certainly put stuff in BSS. The only reason it was hard in my case is that that contains a type that I can't write because it has a closure in it. So it's just one of these like annoying kind of rough edges in Rust right now that like if you want to deal with those types that contain like opaque parts that can't be written, then like usually what people do is they box them at some level, so you're not like you can kind of forget about the specific type. I mean, type erasure, you put it in a box, you forget about the like detailed type, and then you have code kind of outside that layer that doesn't have to know about the specific size or the specific type. So I was able to make some of those transformations to this code on the last stream by when I was trying to kind of take the process, the like per process data out of that one giant table and turn them into individual allocations. So I got that part of the way working. I've got that doing these per process allocations with mmap. But as I said, I think where that really breaks down is when I want to share file descriptor tables. The simplest thing to do, just if I want a file descriptor table per process, would just be to have an array in the process data. And so now that's more statically allocated address space, where at compile time I can figure out an offset into that big chunk of virtual address space that would represent the data for one file descriptor in that process. But yeah, that gets unwieldy if you want to be able to support very large numbers of file descriptors. And the defaults tend to be kind of small in Linux. Like, I think on my system, the default U limit is something like 4096 or 8192 files. But I think you can set the U limit to basically any 32-bit number. I mean, there might be a limit like up in the millions or something, but it can get quite high. So I certainly wouldn't want to have virtual address space for anything that's more than just a very tiny amount of data per file. Like, if it's like right now, I just need an inode number. So that could be just like one U size. I could even have the inode numbers be 32-bit if I wanted, really. But, maybe that data grows in the future, and that could get unwieldy very quickly if I have just a static chunk of address space for each file descriptor, or each potential file descriptor. So, okay, so maybe I want a dynamically sized array of file descriptors. Well, okay, that sounds a lot like something where I need a memory pool. In general, a lot of these operations are things that happen like I'm not worried about optimizing the number of system calls in related to allocating memory per process, because creating a process is already so many system calls. This is a very system call heavy way of doing emulation, and creating a process is entirely emulated. Whereas things like reading and writing a socket, like a virtual socket, that's not emulated at all. That just goes straight to the kernel's read and write. So that should be pretty high performance. But I'm not optimizing this to have super high exec micro benchmark performance. That's not really necessary. So I'm not going to worry too much if I'm always mapping anonymous pages for every single process. That seems fine. If I end up with a file descriptor array that needs to be resized occasionally, that's also probably just completely fine, even if a resize always means that I do an M remap. And then there's resizing the file descriptor array. There's breaking the copy on write, which is actually honestly easier if I can guarantee that I've got separate memory pages for each file descriptor table, because I could actually use virtual memory level copy on write for that. So the approach I'm kind of leaning toward here is that I think I want to use Rust's global allocator interface so that I can use types like box. I don't know if this is going to completely work, but my theory is that might let me still create these sort of large tables of things that I want to reserve virtual address space for, and then turn those into kind of individual big mmap operations at runtime. Maybe I have to subdivide things further still, but I would like to not have a registered global allocator, because I don't want it used in very many places. I don't want this to turn into a general purpose allocator, but if it's mmap backed, then it isn't really going to be useful as a general purpose allocator anyway. And it'll also be easy to get a listing of all my mappings just by looking at the maps file. So I think I'm going to go in that direction. I've still got this code in the tree that adds the mmap, but doesn't interface with the global allocator at all. So yeah, that's the patch we were working on last time. This is the stuff I want to get to after that, where I'm actually starting to kind of thicken the interface of passing files back and forth between processes, so that instead of just being a file descriptor, it's also this V file, but that change comes later. All right. I did go looking on crates.io for existing libraries that would fit this particular memory allocation need. But ultimately, the thing I want is basically just a wrapper around mmap, and because I'm not using the standard libc mmap wrapper, I'd need to write my own like system call adapter for like whatever is actually in there. So like there's basically no code there except the adapters. So I just need to write my own adapter. So a lot of this change is changing that pin interface, like removing it from the process table. Oh yeah, I have another change that might need to merge. Maybe not. Yeah, I think I want to clean this up very slightly and then check it in as just an intermediate change that I don't expect to be useful, but is at least maybe handy to have in the revision history. So I think as this is written, it doesn't actually have any benefit, but it, like the tests might pass. Let's see if the tests pass. Oh, 2 goes back. I need to turn on that crop filter again. Oh, failed. Oh, yeah. Leaving my debug prints in there. So 6 kilobytes per process. That will just get rounded up to the next page, but I'm not extremely worried about like packing the processes together. I feel like keeping things page aligned is probably more useful. But I don't know. It's easy to change later if we decide it matters. Oh, Tuco, are you back over here? Tuco, this is not a convenient spot. Like right next to the door and right behind where I'm sitting. Ah, it's cold, Tuco. Ah, it's cold. Are you done already? Are you not done? Oops. Yeah, I really should automate this process of following the cat around. Did not realize it would still be so important in such a small room. Now it looks like I'm part of Tuco's cat food. She's just laughing at Dad Drago's comment about Tuco using his head like a wedge to open the door. Aw. Yeah, I worry that he's gonna get his head like bonked by the door by accident. So I try to be super careful when he's doing that. Ah, Tuco. Back over here. I'm standing right next to the fiber optic he chewed yesterday. Gosh, I'm glad that the network still seems to work, but I'm still pretty frustrated with that occurrence. That would not actually knock the stream offline, but it would take a bunch of my infrastructure down and I'd be annoyed. And more than that, it would just be an extremely annoying repair job because it's fiber. Like, I don't know whether I would try to replace the cable, whether I would abandon it, or whether I would try to like rent the equipment to splice it or something. Or maybe there are some splices that are not fusion splices, but are chemical splices, and I could try one of those maybe. Tuco, you just want attention? I mean, I'm sure he wants other things also, but he appreciates the attention. There's a question about what the fiber is for. There's a little bit of fiber in here, not too much. I mean, my actual internet connection is fiber, but that's not the one Tuco chewed on. I've got some fiber between a workstation and a file server for bandwidth purposes, but that's also not the one Tuco chewed on. The one Tuco chewed on is actually just connecting my garage to everything else. And it doesn't have to be fiber, but I thought it was interesting to experiment with something that made galvanic isolation easy. But yeah, it doesn't have to be any more than a gigabit, so I could replace it with copper if I needed to. It's not the worst fiber for him to chew on, but it is very frustrating. But I like the idea of the long cable between the garage and the sensitive server rack being completely non-conductive. That idea appeals to me for various reasons. But there are a lot of ways to achieve that. I could, of course, just run a shorter fiber to somewhere here and then use a media converter. I mean, that's actually kind of what I'm doing right now because I haven't fully installed this. So I've got a temporary copper line running out to the garage, and then this box that Tuco is sitting on actually has a fiber media converter that connects that to the fiber that he was chewing on. So it's all making me a bit nervous that Tuco is so interested in this particular area, and I do need to like finish installing this properly pretty soon. Tuco. Well, I'm glad we found a spot he likes. Are we still compiling? Oh, really? Are we still compiling? This seems to be taking too long. We are in cargo build. I don't see any subprocesses in cargo build. Ears. Kitty ears. Dancing on the body of the network equipment he just killed. Yeah, basically. Yeah, it's in one of these big boxes that I got to protect the equipment that I'm putting, or not equipment. Putting equipment in the attic would probably be a fire hazard, but I've got some like network splices that are going in the attic, and I got some boxes to protect those. And he's sitting on one of them. So it's kind of sturdy. Oh, there's a cool spider on the ceiling. Wonder if my camera has enough zoom to get that. Hello, everyone in chat. Happy Friday for folks where it's Friday. I think it's Friday in a lot of places now, but I guess it's probably already Saturday in some places. How do time zones even? Gosh, this test that always takes so long is testing actually downloading a container and looking at the progress updates. So I suspect that one will be annoying to have in the test suite, and maybe I modify it at some point. So far, Docker Hub hasn't tried throttling me. At least not that I've noticed. I think Tuco appreciates that the weather seal on this door is bad, and he gets a little bit of cold air if he sits right here. He seems to generally be a very kind of tropical kitty. Like, he likes the warmness most of the time, but he also likes the temperature gradients. Like a little permo couple. Oh gosh, Trevor is asking in Twitch chat if Tuco chews cords a lot because they're worried about getting their own furry creature because they have a lot of special purpose cables they can't replace. Yes, Tuco will chew basically anything, but especially wires, and it's really hard. It kind of drives me nuts protecting everything from him. And I've tried a bunch of things. The thing that I found that works the best is this kind of automotive style split loom tubing that you see all over the place. If I ever zoom out, like, you can see it all over the place. Like, it's all over these wires. That's all because Tuco chews them. Yeah, Tuco will chew anything he can, but he especially likes kind of big, thick, meaty cables that have a lot of rubber on them. So he would love to chew things like extension cords if I didn't protect those very thoroughly. So yeah, it's a big problem both for the equipment and for health and safety of the cat. So yeah, it's been an ongoing struggle to keep all the wires protected from this little guy. But if you like cats, I wouldn't let that stop you. I mean, it's a lot of work, but there's options. If you find something that works, you'll be able to just protect all your cables somehow. Like, I would definitely recommend trying the split loom stuff. Tuco could bite it if he wanted to, but it's just the texture does not appeal to him anymore. I've heard some people have good success with like bitter sprays, but Tuco didn't seem to care about those at all. Yeah, I did try some bitter, and I didn't try like a big variety of them, but I think I tried one or two, and Tuco didn't care at all. They didn't last very long, and they didn't really deter him. Yeah, well, good luck. Good luck with your kitty. Like, there's often, like, I don't know about your area, but like most areas have animal shelters with a lot of cats that need homes, so you can probably find a good friend there. I was super nervous about getting Tuco. I didn't adopt him from a shelter. That's probably what I would have done if I was planning something more intentionally, but I ended up adopting Tuco somewhat randomly when like a friend of a friend just had a cat that they couldn't take care of and basically like put him up for adoption on a email list like for friends of friends, and so I got connected with this person, and like it was all extremely random, and I certainly would not trust a process like that in general, but it did manage to connect Tuco and me. 404 says they don't understand people who like bitter taste in food. I mean, I'm one of those people, but I don't really understand it. I I sometimes imagine that I just like the taste of poison, but I don't know how true that actually is. Oh, what are we doing here? Oh, right, this is the test I had disabled because it doesn't actually work yet, I think. No, I thought that test ran. Is this a transient failure, or does that always fail? This is why control experiments are always useful. Like, it seems like a waste of time sometimes to run a thing when you expect it to work, but it's super important, otherwise you don't know if the failure means anything when you have a failure. So I'm always encouraging control experiments in people's hardware and software debugging setups. Oh, Trevor says they do SRE and the new Docker Hub throttling is super annoying. They've got a big registry mirror set up now. Yeah, that could be useful. I've got a little local registry server here just for testing, but I don't have much that's actually useful on it, and I certainly haven't tried mirroring official images on it yet. That might be nice to set up. I assume there's some kind of like pass-through mirror, like caching proxy kind of thing that you can set up. I haven't actually looked into that yet. That's interesting. So we have a transient failure. That's not fun. I think that was... Oh, actually, that's not enough information to tell. This exit code is just always the exit code that we get when there's a container panic. Gosh, transient failures are annoying. I kind of want to get to the bottom of that. I don't know if that's new either. Just run this test a few times. Let's just do Ubuntu LDSO. Oh yeah, that'd be nice, having a transparent mirror set up locally. I should definitely look into that. Another report that somebody's been getting throttled randomly unless they use a free throwaway account. Interesting. I haven't even tried the login support. Like I had to implement my own registry client, basically. Like the protocol is pretty simple, so that wasn't a big deal, but I did have to implement the authentication I tried a couple of other like Docker client libraries. There was one that was a pretty good match for what I wanted, but I had one giant nitpick with it. Well, I guess more than one total, but there was one like last straw really where I couldn't find a secure way to download a manifest with it, which was super annoying. So at some point I just had enough with that one and started writing one kind of from the HTTP up. But yeah, as a consequence of that, like I have definitely not tested authentication. I wrote the code for it, but like to download images at all from the main Docker registry at least, you do need to log in, but you can log in as a, I don't know what the right terminology it is. I think you're authenticating, but you're not actually supplying any credentials. So it's like you're logging in as no user. So it's sort of a weird requirement, but it seems to need that. So that's all I've really tested is that and completely unauthenticated access. Does the cache state matter, I wonder? That shouldn't have run so quickly. This must be using the other cache. That might have been... I should check on that beep. I don't know if that's mine or somebody else's. Well, it stopped. It stopped, and none of my equipment is complaining at me on the computer screens, so I'm assuming that's someone else's. Doesn't quite sound like my UPS beep, but kind of close. Yeah, maybe that was an I/O error, because this is a network drive that my cache is sitting on by default. I sure thought I had set that, but maybe I just didn't reload the environment in this shell. Oops. Let's just try that. That's slow enough that it's actually downloading, right? It's not giving me the progress information because the test is capturing the output, but normally I would have some progress bars at this point. While that's doing its thing, and I'm worrying about transient failures, let's look at the global allocator docs. Oh! Okay, that is reproducible. Let's see if I can reproduce that with more logging enabled. I could run that, like I could try to reproduce that same case using the CLI app, but I could also just set rustlog equals trace and run that again. Can I loop this? Can I just use that whole thing as a condition? Stuco leaving us for the moment. Maybe we'll reclaim some of the screen space. So the actual error here is this initial exec failed, but why? So there's an earlier instance of that exec failing. That's an emulated exec, sys59. Hmm. That's interesting. So I think this is set up to resolve libraries at a bunch of different places, like maybe even depending on the CPU flags that it detects. So I wonder if my CPU ID flags are not reading in a stable way. I'm passing some CPU ID flags into the binary I'm running via the elf aux vectors, and that code is basically completely untested at this point. Like, I wrote it, it seems to work, but I haven't looked at it super closely, and if that's broken, it could cause this kind of failure maybe. But I don't know that for sure. I definitely need to verify this more. I'm going to try getting logs from the working and non-working cases, which would be easier to do without running this via the test harness. So let's reproduce it on the regular command line tool. I feel like I can still check in this change though. Like, I don't know that this introduced the transient failure, and if it mostly works, then I'd still kind of rather check this in than not check it in. I can improve it. Tuco is very meowing. He likes to do this thing where he goes somewhere that's just like a little out of my range and meows to try to get me to come closer. Tuco. I think we can use release so it goes faster. We don't get any less debug info in release. So that's interesting. So we were loading another version of LDSO from inside of LDSO. I don't know if that's a normal thing to be doing. So like this might be the result of some kind of uninitialized memory mess that I've left for myself. Yeah, that's interesting. Concrete says that their cats do this too. Sometimes in the evening, the cats go into another room and do mournful meows, and then you ignore them long enough, they come and cuddle on the couch. Yeah, that sounds a lot like Tuco. I find it really hard to ignore Tuco. I've taken to some like fairly industrial strength methods lately of using like big the kind of headphones that you would use for like operating power tools, and then in addition to that, piping noise into those. I feel like I need a dedicated device for that now because it actually, like, I actually have a huge problem when Tuco's in one of those extremely meowing modes, and I'm having some trouble getting my headphones to Bluetooth pair to my computer or get the audio player to cooperate or whatever. It's like in cases like that, I just want a hardware device that I can put on my ears that just produces noise. So that might be a project at some point. Let's ask for lots of debug. Okay, and why not? How terrible is that? Interesting. So it looks like we've got a couple of different sizes with 127 exit codes, and then the 60 is much smaller. Oh, can we just make these numbered, maybe? You do want to be bounded or something. Why not? Oh, now I'm getting more questions about the headphones. Sorry. No, I don't mean noise canceling headphones. I'm literally talking about a noise generating device. It's like exactly the opposite. But yeah, so I've been using these lately. What are these actually called? They're 3M work tunes. They're kind of dorky looking, but I actually find them to be pretty useful. Like, they block out enough sound that you can use power tools and stuff. They just without any power, it's already kind of relaxing. It's like just everything is a lot quieter. I can still hear Tuco through these plenty, but then additionally they have Bluetooth, and I can just like play like pink noise or something from my laptop. So that's what I've been using to block Tuco out when I really need to block him out lately. Noise generating headphones. Is that just normal headphones? I mean, yes, that's what I'm doing right now, but I think it would be even more convenient if the headphones didn't have to be connected to a computer to generate noise, because I often find that like if I really need it right now, then that's often when the computer is not cooperating. So it'd be cool if I could just add a knob on the side that you could turn up and then it would just generate noise. Okay, so that's doing some stuff, whatever. Let's mostly be looking at the files, probably. I think I'm going to grep these for task call first. It does look like it's usually opening itself. That's interesting. We got some examples of working and not working logs here. So most of these just have small differences. Like, let's try, sort of look at these three, 917 through 919. So 919 is the one that crashed early. Whew. Oh. Yeah, that's got to be get CWD and uninitialized memory. Yeah, I don't think that's really a problem. I mean, it is a problem right now, but I think it's a problem because of unimplemented code, not because of something that I've implemented in a grievously wrong way. So that's not really concerning. I think what we're doing here is that there was a get CWD call up here somewhere that I just wasn't implementing, and so that left the buffer uninitialized and didn't null terminate it or anything, which is normally going to give you an empty string because this is stuff that's running shortly after the heap is set up, but not always. And so I guess something that happened differently during this run, which could have been timing related or it could have been address space layout randomization related, caused this string to appear in that address instead. We can maybe try to verify that, but I don't think all that info is going to show up in the log. So there's change working dir, but I thought we were also doing a get CWD. Oh, that's right. That is not actually going to be labeled as get CWD. That'll be labeled by system call. Oh, I should just get my own system call table instead of going to this out-of-date blog all the time. Sys79. Oh, is that not the right version? Could be my theory's wrong. So what other system calls do we have here? Oh, now I'm starting to doubt my theory and starting to wonder if this is a concurrency bug in the inter-process communication code. Yeah, this is all happening much earlier than I was expecting. So what can we eliminate here? So these emulated sys2s are opening standard I/O, and I have no reason to believe those are failing. This 4, 7, and 9 will turn into 0, 1, and 2 in the new process, but right now they're not. Sys 21, is that where the actual failure was coming from? That... I think this always fails. I think this is trying to open like an LDSO preload config file. So I think that's fine. And then 12 is break, which... So these are actually not in the sandboxed program. These are actually in the loader. So we haven't even gotten into the sandbox program yet. So these are break calls in the loader. This is access from inside the loader. This is my code in the loader opening standard I/O and preparing that. Then, or yeah, that's the end of opening standard I/O. That's sys2. And the 80 is changing the current directory, which isn't implemented yet, but we return success. And then 59 is the emulated exec. So, yeah, really? So this isn't a problem with the sandbox code. This is a problem with the path that we're getting. So this might be a problem with the networking code that deals with the initial arguments to the container. Get CWD sounds like something that would be easy to implement. Is that right? I mean, not really. I mean, it's like open. It's like, would you expect open to be easy to implement? It's a basic fundamental thing, but it's also like it really gets to the heart of what we're emulating. Like open actually involves looking something up in the virtual file system and then setting up a bunch of objects and then passing those objects around to different processes. And get current working directory is sort of similarly fundamental. Like it involves setting up a relationship between the emulated files and the like the emulated file descriptors and the actual virtual file system behind that, which is what's leading us down this particular memory allocation path. And then it's also complicated because it's dealing with strings and a remote address space. So like that's never super straightforward. So there's always a bunch of details inside there. If you want something that's really simple to implement, I don't know, what's a canonically simple system call? I'm thinking like get PID. Get PID is simple. We've got get PID. Yeah, that's like the canonical simple system call. A lot of system calls are much more complicated than they appear, though. My uname is pretty simple, too. It does have to copy... Well, no, actually... Yeah, actually my uname is kind of complicated because the data that I'm sending back is simple, but the process of getting it there is actually really complicated. Okay, so this seems to not be a problem with system call emulation, but it seems to be a problem with the loader. Let me see if I can verify that hypothesis. Gosh. This is a very interesting bug. I feel like I need... Well, I probably need to add some more logging to the code that generates the initial argument set and the file name and all that. It's actually, the get CWD question is pretty interesting, though. Now I'm kind of curious, like, what would it look like? What does Linux's get CWD implementation actually look like? Because that might be kind of interesting to compare this to. So yeah, I think dpath is for dir entry. So it fits on a page. Like there's some esoteric cases in here. So like if we... Yeah, that's actually pretty interesting. I hadn't thought about this, but this does actually have to generate the path by walking from the inode that it's at back up to the root. So, and I'm sure I'm going to have to do the same thing actually, because I do just have an inode number, and the inode itself does not have a path. The path is the path that you use to reach the inode. So I think I'll probably have to follow the dot links. Might have to look into that in some more detail. But then, like, inside each of these, there's some more complexity. Like, what does this even do? Like, how are we allocating memory for a growable path buffer in the kernel? Like, is this kernel memory? Is this user memory? Like, there's tons of details inside each of these. I mean, it must be kernel memory because we've got the copy to user down here, but... and so this isn't actually variable sized, it's all path max sized, which thankfully is like static, so the kernel code can be easier because of that. But then, I mean, you've also got layers for the directory entry cache and is that what this is? D unlinked. But then, so like most of this is just like formulating a string with the path and getting the string back to user space. But then this get fs root and pwd, what is that? P, print working directory, path working directory. I don't know what that actually stands for, but we need to figure out what that does to actually know what's going on here. And that's actually just up here. Oh, yeah. So then I think this is some kind of in-kernel iterator sort of data structure, but I don't actually know what's going on here. Oh, right. So there's actually an in-kernel sequence number that's used to like synchronize changes to the directory structure. So we might actually have to do a retry if we read the directory while someone else is modifying that directory. I think that's what's going on here. So this is like a lock, basically, but it's a special purpose kind of lock based on this file system sequence number. And then we're copying this data out of the fs struct. So like, where is fs struct? Which of these pager alerts is going to be the fiber actually finally failed? So far, none of them. Oh, let's open that in Emacs. Loading Linux. There's a question where Tuca is. I think Tuca is. I feel like I can almost see him from here. I think he's on his warm spot on the opposite side of the house. So yeah, this is basically what we were doing, but split out into two separate pieces. fs struct, we have a struct path for the root and pwd, which is that process working directory. And then a path is a virtual file system mount and a directory entry. Is dentry an opaque structure here? I tried to get C tags set up, but it just took so long to generate it on this tree. It seemed like I was doing something wrong, and then I gave up on it. Oh, is this in Dcache? Yeah. Ernie says it's weird to see how few dot comments there are in the kernel. I don't know that it's super weird for kernel code. There is actually a decent amount of documentation, but a lot of it is in separate files because it's more like long form descriptions about how things are supposed to work. But yeah, I mean, Linux is generally like it's not very well written code. Like it's not very clean. It's not very easy to read. Like it gets held up as an example a lot of the time, but it's not actually that good. Like it's actually kind of a mess a lot of the time. That's interesting. Inline names. So it is doubly linked. Yeah, so that's cool. That's also neat. Randomized layout. Is that just to make this harder to exploit? That's pretty cool. Probably harder to depend on, too. Like, they probably don't want people like writing modules that actually poke around in here. So yeah, currently my equivalent to all this is vastly simpler, and it'll always be able to stay much simpler, but I'm going to need to add at least a few more things to my virtual file system to actually make it work. Man, I don't know what to do to debug this piece of code. It doesn't normally have access to standard I/O, but I could rig up something to give it standard I/O access temporarily at this point. I'm just trying to think about what would even cause a failure mode like this. Like, the thing that I find myself wanting to know the most is I'd really like a copy of the header that precedes the variable length initialization arguments for the sandbox. So when this all starts up, there's the first application here is either your network video server or the CLI or something. It's like some host application, and that prepares a buffer with the initial arguments. So that's command line arguments, environment, working directory, and the program to run. And it just kind of squishes all those strings together into a buffer and writes a header that describes the length of all of them, and then sends those out to the process. And it, on the receiving end, it just receives that into just one big block of memory. That's actually one of the next things I was going to change on the memory front. Is I'm using alloc A right now to stick that on a stack, and I think I'd actually rather just do another special purpose or just like single purpose mmap for that. But thinking about what would cause like a copy of this string, like it looks like, we've got a prefix of the path, and then that was truncated, and then another copy of the path. I might just add some debugging in places where it's currently easy to add debugging and see if that tells me anything useful. What's going on there? Why are those pointers different? Oh, that's the working directory. Gotcha. So these are very close by because they're just one after another in memory, but this is just a null character. I always get thrown off by the order of these arguments, because this is actually the system call that we're emulating up here, but it doesn't get logged until we're actually finished with it, which is kind of annoying. I should probably have a separate log for starting to emulate the system call, but then the logs would be even more verbose. I might just check over the network code that sends this. That sends and receives this. Because this is a C string, like the length in that header doesn't necessarily need to have changed as long as someone actually like splats another copy of the string here. It's gonna read until the null terminator. So like the right side of this seems pretty straightforward. We're sticking all these values in one of these buff writers, sending it via a Unix stream. It's also just easy to log that. It's easy to log that, but I also really can't imagine that messing up. So maybe I'll put that off and look at the receive end first. This totally seems like the kind of problem that could come up with like a receive loop that misunderstands the number of bytes in some edge case and doesn't advance the buffer by the right amount or something. Gosh, I was about to rewrite a bunch of this code anyway. I'd like to know about the bug, though, if possible. It's just a weird failure mode. Like we're not even doing separate reads for those strings. It's all one big read. It would be kind of useful to have strace for this to see the read system calls, but this part of the code is also really hard to strace. Like we don't normally trace reads and writes, so I can't normally log them in my tracer, and you can only have one tracer at a time, so I can't also run strace. It'd be handy to just print some of this stuff out, but this is also where I don't really have print. I can panic. Does panic actually work here? Yeah, panic works here. So if I write to standard error, that doesn't go to the real standard error, but it goes to a socket that the runtime collects and turns into a Rust error at some point. Yeah, maybe I'll actually just modify this to panic and log some of these values that I have questions about, and then just run that a bunch of times and see if I can get sort of non-standard results out of that. Can I log strings here? It'd be useful even just to have like a general purpose hex dump utility. Oh, there's a question from the chat about what I'm working on, which this is actually probably a good time to talk about this. I'm kind of deep into debugging bits and pieces of this, but I'm working on a kind of small, relatively special purpose sandbox runtime that's written in Rust and is intended mostly for doing things like video transcoding. So there's some code. The stuff I was intending to work on this stream was mostly related to memory allocation, although the thing I'm looking into like right at the moment is kind of an intermittent failure where sometimes it just runs the wrong file name, which seems concerning. So I'm trying to get to the bottom of that. So this code runs in an especially weird environment. Like even in the whole gallery of weird environments that this particular project presents. So this is running in an environment that I've been calling the loader, which is technically just another copy of the sand process, but as soon as it starts up, it specializes into being the loader, and its job is just to set up a few things in memory and then call exec to get into the actual sandboxed process that we're running. And this runs entirely inside the tracer, so all of the system calls that would normally be emulated are emulated here. And like it can call open, for example, and that turns into an emulated open with an interprocess call and all that. It doesn't have direct access to the interprocess communication channel, so it can't actually talk to the runtime. It can just issue system calls. So that's why it does things like, it just calls an exec, like a regular exec system call here. But this is actually acting as an emulated exec that's trapped, and so it's a little bit more like a hypercall in this case. We could have custom hypercalls here because like both endpoints are under our control, but so far there's no need. The closest thing I have to like a custom hypercall really is the way that I set up standard I/O. Where is that? Oh, standard I/O is actually set up slightly outside of that. Oh, where did I put that? Oh, it's in sand-lib. Okay, yeah, this is only used for the loader, but it's here in sand-lib because I don't really have a separate file for that stuff. I guess it makes sense that we have both of the two kinds of standard I/Os here. So in the tracer environment, standard I/O is weird, and in the loader environment, standard I/O is differently weird. So in the tracer, we don't actually want standard in or standard out. But if we just closed it entirely, then those file descriptors would get reused, and we'd actually want to keep them available. So we're just dumping copies of standard error on top of standard in and standard out, and then going to extra effort to actually scrub the file descriptor table and close everything else that we don't know about. And then on the loader side, we're opening these kind of weird paths, and that is definitely a special path as far as the runtime is concerned right now, but I don't know if I'm going to keep it that way. Let's do the thing. So I just want to debug that file name thing. Is this just access? No, faccess at. That's not what I want. Yeah, I'm just using this as a way to log this string for now. I could add a dedicated like log string from sandbox address space thing, but I don't currently have that. This runtime normally does not actually access the contents of strings. Normally it would just pass around a pointer to a remote string, and then at the point where the virtual file system needs like a local string, we'll actually read that in once from the remote address space. So let's just do a throwaway access here. And I want to debug that header. Okay, so I think that'll give some useful output. I guess we can clear up the screen while 2 goes elsewhere. Oh, yes, he's back. I thought that would work. Okay, we have a panic. Is it a useful panic? Why did that get mixed in? Oh, right. I'm getting confused about standard error again. So if we write to standard error from the tracer process, that'll go to our output socket, and we'll catch that. But since we're in the loader, I was just showing you the standard out setup for the loader. We've got that emulated standard I/O. So this is actually going to the emulated standard I/O, and not the real standard I/O or the exception logger. Which is fine, I can get it, but it just means that it's not like synchronized with the actual log output. I think these are both going to standard error also, they're just not synchronized, which is annoying. So I think I'm just going to read this the way it is. So I've got the log data kind of messed up and interleaved, but those 2 pieces are the header that we logged in the panic message. else is useful here. Do we actually have that access? Why is that a null pointer? Oh, because I didn't put the pointer in there, because I'm just a doofus about that. Clearly, if I just leave out arguments entirely, I'll get the right result. I don't know if this is going to help, but I'm going to add some carriage returns. It might increase our odds of getting that message in one piece. Sorry, new lines, not carriage returns. The other line break. Tuco is very meowing now. Tuco? Oh, what does he even want? Anyway, what do I actually want out of this? I think I'm just going to do that same experiment where I run this a bunch of times and collect the outputs in files, and then I'll use grep to sort them out. Let's actually... do that. Meow, meow, meow. Ooh, there's a corrupted one. So different specific string, but similar kind of corruption where it looks like it's just reading the same portion multiple times. So that was in 211. Oh, Tuco wants to run on the wheel. That's the sound of wheel. I wonder if he'll run if I bring the wheel in here. Tuco, you want to run on the wheel on television? He really wants to run out here. Tuco, can I interest you in moving on set? Here. Can I carry the cat and the wheel? Hey, Tuco, you need the base also. It would be kind of cool if I could keep the wheel in here. I think Tuco would appreciate that. It's a little big, but there might be enough room. Maybe he'd meow at me less if he had some exercise toys in this room. Whoa, hold on, Tuco, it's not quite ready. Okay. Is it running time? This is super awkward for me, but Tuco likes it a lot. I'm always at risk of my glasses falling off. turn off that crop filter. Tuco, you want to run? Hey, Duke. Are you done? That's cool. Maybe he'll get back on that on his own. Oh, did you just want to go the other direction? Oh, that's kind of cute. You want to go that way? Tuco, you're such a cat. He also likes just sitting on the wheel sometimes. Oh, Tuco, this is kind of a good spot for the wheel. I mean, it's slightly in the way, but so is everything else. Scratching post. Kitty. No? Keeps getting dangerously close to being interested in that fiber optic cable again. Right. That black line to the left of that closet is the same fiber optic cable. Oh, you want more? Which way? This way? What do you want? Oh, Tuke. He's so weird. Oh yeah, this has come up too. Subshrub is wondering if he'd like a motorized wheel. I was thinking about that. I got kind of deep into a thought experiment of how would I design a wheel that is like safe and interesting for him to use. But I think a lot of it is that he wants me there like as a running partner. It seems like he enjoys the company and he doesn't need me to push it. He just likes me to hang out there with him. Arnie's wondering how come Tuco actually uses this scratching post. Their kitties prefer a stair carpet. Yeah, I mean, Tuco scratches plenty of other things, but he does seem to like the scratching post. I think he specifically likes this one because it's so tall. He can just like reach up and like stretch out like big stretchy cat. Oh, Tuco. Is that what you want? Cat channel. He's just so interested in the boundaries of his world. I can sympathize. Hey, Took. I'll open it briefly, but honey, it's cold. Careful. Oh, it's cold. Tuco, there's coldness. There's so many coldnesses. He'll be tired of the coldnesses soon. like now? Or do you like that? Tuco, are there cool birds? Ah, there might be cool birds. It's also suspicious that I think in this case, the file name and the argv are back to back and have basically the same contents. So instead of like a duplicate copy of the file name, it's quite possible that some data is just getting skipped. Anyway, that's not super illuminating. As I expected, I don't think the size is changing, but it is still reproducible. I think the next step is to get some more debug info about the return values from read. But most importantly, cat. It is cold though. Tuco, why do you like it? Huh. It would be kind of nice to just dump the entire contents of this buffer. It's going to give me this annoying integer array, but I don't think that's actually a huge problem. I can just convert it with something else like Python. And I could convert it to a string here, but and what could I do here? I could interpret it as a string slice and then print it with like debug, and then I get it escaped stuff when it's not actually printable. Maybe we should do that. I've always got to remember, like, okay, what can I actually call in this environment? And like, things that just use core library are fine. Like, oh yeah, actually I can't. That isn't actually in core because that might need to alloc. I was thinking about from UTF-8 lossy. You want the screen? Okay, I can bring the screen back. Sorry. I just find the cat more interesting, but then like I've got more screens here. Oh gosh, what was I doing? Oh, this is in core. That's interesting. I don't know if I want to use that, but it's interesting that that exists. I think everything in there should be valid UTF-8s, but it will contain embedded nulls. I think that's fine. Let's just debug that whole thing. I think I just want another reference. I don't think I can do that though. Oh, you know, I can't actually print it up here. And that'll just stick around in the standard error buffer until the panic right down here. I think that's perfectly safe here. Tuco's still into the cold. It's actually not that bad right now. Oh yeah, that's a good point from Game of Knowing that this is probably the first time Tuco's had such a close-up view of the seasons changing and all the wildlife and stuff. Yeah, the last place we lived was a bit more removed from the outdoors. Like, we had a good view of birds and trees and stuff outside, but I mean, here we've got an actual backyard and there's like birds and trees and stuff like right there, so it's certainly different. When we moved in, it was approximately this time of year too. Yeah, when specifically was that? I think Tuco and I actually started living here last, like, early February or late January last year. So we were here for part of a winter and the entire summer. Oh, that is remarkably readable, actually. I'm sorry I ever doubted you, string UTF-8. I'm like, I'm like forgetting about the power of debug prints in Rust, because it's like so many things have actually just very nice debug formatters. And it's nice that I can have a nice debug formatted string without having to provide an allocator. I mean, the trade-off is that I have a bunch of tiny write system calls, but for a debug print, that's totally fine. Anyway, let's just run this a bunch and see if I can get it to mess up again. Tuco. warm this time. Ah, now the wheel's in the way. I should have deleted the old ones so that I would have a clearer idea of which ones are actually new. Yeah, impatient. Oh, there's one already. Log.2. What luck. Okay, so clearly the path is fine up here. Exec file, lib, x86, 64, Linux, GNU, whatever. Interesting. I'm just going to add more debug prints, because this is very interesting. So, I mean, the string looks fine, which means the problem must be after this. I wonder if it's a problem with the actual vstring read. That would be pretty weird. I would like to close the door now, but I feel like Tuco is going to come right back over here and demand that I open it if I do that. Should we try that? Because I'm kind of cold, and Tuco's all the way over there. Alright, door's closed. How long before Tuco demands that I open it again? That double null termination is normal. This is a single string, and then the second one is a list of strings. Ooh, there's some. 69. And still fine here. Oh, could this be related to the memory alignment, maybe? It does seem like I should throw a bunch of debug logging into the vstring reader. That is my next suspicion. All the logging from the loader process seems fine so far. This is a bit roundabout because like what we're doing is the runtime is packaging up these arguments, sending it through a socket to the loader. The loader puts it in its address space and then issues an emulated exec. And then the emulated exec then has to slurp those arguments all back out of the sandbox process or the sandboxed process's address space. But I implemented it like that because I wanted the very first exec to run through the same code path as additional execs. So I have to implement a loader and then exec rather than having to implement multiple kinds of exec. So remote mem. Oh, Tuco, you're back. Gonna demand I open the door again? That was a nice yawn. That was mostly obscured. I should refresh myself on what code path that particular vstring lookup is going through. So this is using argstring. That just wraps the pointer in a new type. That's right. It's not even in this process. I was looking in the wrong process. When is this called, this vstring length? Because like I was saying earlier, we don't usually need to worry about strings in this process. I forget where that's needed. Wait. Hmm. 64. I don't think there's anything wrong with this. This all happens much later than the failure I've been looking at. I'm just being slightly annoyed that like during an exec, we're looking at these strings once to calculate the length, and then we do actually still have to copy them separately. This isn't part of a security boundary, so it's not actually like a time of check thing, but it is kind of annoying. But yeah, that just answers my curiosity. This vstring length is used to calculate the size of pieces of the initial stack during exec. Because that is done in this process. All the exec emulation is done in this process. Okay, on the other side of this, so that access turns into a task call, and those go through user string. User string calls process.readString. Is it not there? Oh, right, not the sand process. This is almost certainly where the problem is. Yeah, so does this have to do with the page alignment of the string? So here's one that failed that was right at the end of a page. Here's one that failed right at the end of a page. This has got to be just like a fence post bug in that I've got to have a test case that covers this, because this is not the kind of thing that I want to just happen without having tests. Oh, how am I even doing the tests for that? Like, I don't currently have a good way of running tests that depend on custom code inside the container, but I'm sure that's going to be necessary at some point. It might just be the part of the build step is that I've got to build another crate in my workspace that is like tests that get turned into a Docker image. But I don't want to have to depend on Docker at build time, because part of the goal of this project is to keep the dependencies light. So yeah, I might do something where there's a test that runs in the container that uses, I don't know, something I don't have to like precompile, so like an interpreted language maybe. But I don't know how I'm going to do these super low-level tests like that. Where like I mean, actually, I could do this in Python, I think. Like if I wanted to write a test case for this bug in Python, I think I would just need to allocate page-aligned memory and then like open files using strings that have different alignments into that page. So just to talk about context a little bit, I'm trying to track down an intermittent failure in one of my tests, And it looks like it's a problem with the string reading code that's related to the page alignment of the strings. And none of this is very surprising. Like, that's definitely a spot where the code has edge cases that could be problems, and there weren't any tests for this. So I need to fix the bug, but I also need to make this code testable. And it's fundamentally about reading stuff out of a different process. So I kind of need part of the test case to run in that other process. So I could set up something small just for that. It's also tempting to just make this more of an integration test, which is what I was thinking about in terms of just like running a Python script inside the container. I can't run Python yet, can I? I mean, I can't generally run dynamically linked programs, and I'm pretty sure Python would also depend on stat, so I'm pretty sure there are a bunch of reasons why I can't just run Python code yet. I mean, I'd like to, but... Maybe I can make this code unit testable. It'd be cool if I could just have unit tests for this. I might just make some test scaffolding that lets this read stuff out of like self maps. Like either calling this using the current process PID or actually opening proc self. How easy is it to write tests that you expect to... I was going to say segfault, but actually that's not an issue here because this should never segfault. That's why I'm reading using file system calls instead of mmap, specifically so that I can make sure it never segfaults. Okay, well maybe let's clean up this mess that I've made and then start trying to make a test case for this thing now that I know what's failing. Oh, we didn't need hair cam, did we? If I turn off the camera, maybe Tuco will come back. Let's see, so I think this can actually be fairly straightforward test code because I already have a way to do memory mappings. Do I? I already have a module handy that can do like file memory mappings. I might need to drop down to a system call to get an anonymous mmap region just for this. Does anyone else have the hardest time remembering whether something is singular or plural in a string like this? Is it config test or config tests? The world will never know. What do I have tests for? singular. I just had to find somewhere else where I was doing it, and it just kept striking out. But for some reason I keep calling the module tests plural. That's probably not helping. It is the test configuration single in which there exist multiple tests. And then that's singular. I kind of just want to make system calls directly here, but that feels kind of lazy. Like, I'm already using libc in this part of the program, at least. I could use memoline also, but mmap seems closer to what I actually want. Why is gitpid unsafe? Oops. What is process status doing here? I don't know if that's actually even something that belongs there. No, I think past me was right about that. I don't really have much of this yet, but I'm going to need basically per process file system state somewhere, and I think that's where I decided it could live. Thinking about whether to split this up further, but at the very least I need to pull like read string and read string OS somewhat out of here. I think I want a process mem object. I keep using the word object even though I don't know if that's actually what I mean here. we don't need to be super pedantic about whether this is object-oriented programming, do we? Yeah, sure. Maybe. I kind of do want this process mem to be in a separate file at this point. Yeah, I don't know. I mean, that's most of what this file is the process memory. There's, like, this needs to open the maps file, but this doesn't really have to do anything with the maps. It just needs to pass that on to the lower level process. Maybe I do want to make this public. I actually just want mmap here. Hello, folks that are new in chat. I'm mostly working on this Rust sandbox project, but things are a bit in the weeds with debugging right now. And I was trying to trace down an intermittent failure that I now know is related to a bug with reading strings that are at the very end of a page. And that was kind of a blind spot for my testing, and so I'm trying to figure out how to test that. And I mean, I think at this point the testing is relatively straightforward. I'm just kind of fussing over making it kind of neat and tidy. I'll be right back. Hello, world. Yes. There is a hello world. It's kind of complicated, but it works. That's interesting. Game of Knowing is wondering if I'm using any project planning systems for this, or if I'm just keeping everything in my head and using GitHub issues. Yeah, I mean, I'm mostly just writing the code. I like this project is way too new for it to need any kind of like planning tools, really. Like I'm not gonna pretend that I know how long any of this is gonna take. Yeah, I don't really want to make this more complicated type-wise. I think I just want to actually just pull those functions out. I don't see any reason for those to be public right now. This Emacs plugin doesn't actually understand how to format these, but Rust format will take care of that later. Okay, now I need to do some memory mapping. Let's make some pages. Let's pick an odd number of pages, why not? Totally arbitrary. It's like slightly more types than I'm used to with a map. But just slightly. why does this return a pointer? The return value of mmap is, it actually kind of acts more like a result of pointer and arrow. But I think the way this is written, it's just going to give you like an invalid pointer on error and make me deal with that. This is not actually more convenient than the raw system call. I mean, this is just a test, so I don't extremely care about handling errors here, but I should at least assert. Start by seeing if that compiles. Start by seeing if it formats. Yes. Malcolm's asking if I have fun doing this. I'm not really sure how to answer that. Oh, that's right. I have ABI page size in the lower level code because that depends on a bunch of low level hardware stuff anyway, so I just define it there in the hardware specific code, but here I'm actually using libc to find it at runtime. Programming is a mix of emotions, but mostly frustration. I mean, you're not wrong. I feel like programming is a lot like enjoying the taste of bitter things. Like, it's funny, I don't want to discourage people from programming if they're interested, but I feel like there's this culture of kind of trying to tell people that programming is much like more exciting and sort of interesting and like predictable than it really is. Like, real programming is often just a mix of like banging your head on the same problem over and over again, with like also just being like extremely delighted with something that you've produced that actually works right. So yeah, I don't know if I would call it fun. I would more call it like deeply satisfying at moments and sort of overall like a worthwhile thing to do sometimes. That's kind of how I would describe it. Oh, did I forget what? Oh, it's right, not void, it's null. I'm not trying to create a void. do we never use that? That's interesting. I wanted to keep those lower level functions read bytes, and I mean, yeah, I think I'm just going to allow dead code on them for now. Oh, right, that's in super. Yeah, a worthwhile thing to do sometimes, life in a nutshell. Yeah, basically. That's pretty much all you got. Things that are sometimes worthwhile. All right, file descriptor. I32. Interesting. In that case. Why is this signed? This is part of the larger confusion between whether something is signed or whether it's a result type in libc. Like in my opinion, in my estimation, the result of a function that could return a file or an error should be a signed int, whereas something that is definitely a file should be unsigned. But that's just me. Okay, so we open self-mem. This is an RAII type, so this will close when it goes out of scope. This we're unmapping manually. So in here we should have access to self-mem, and we should have a mapping. So we can start to read from the mapping. Cool, so that compiles, and yeah, we can start to do stuff. So first thing to do is probably just to read from various places and make sure that we're reading nulls where we should, and gosh, it would be nice to have a page that I can use as a guaranteed fault. Maybe I should manually map some guard pages here. Because if I'm writing a test where I want to read from the page and have that succeed, and then I want to read from right after the page or read past the end of the page and have that fail in predictable ways, and I can't write a reliable test for that if I don't control what's in the page right after the one I'm testing. So I think I do need a guard page. Yeah, okay. Call that map RW size. Let's make this a little more compact because I'm going to need two maps now. Oops. Okay, so the guard page has no protection flags. It is anonymous and private. This should be map RW size plus Is it a pointer? Is it an error? Who even cares at this point? I just wanted this so I could pass it directly to here. I'm not going to bother checking the return value of this libc map. If this fails, the test is just going to segfault. That'll be fine. Let's combine these unsafe blocks. Alright, so we've got guard pages. This should be the total size. Okay, so the main entry point I'm trying to test here is read string. It internally uses read bytes and read string OS, so I could test those separately, but I might start with just like a little mini integration test here. Oh, I just saw the comment about mprotecting pages. Yeah, I mean, I could use mprotect also to change the pages on one allocation, but I can also just use map fixed, like it's just six one, half dozen of the other. This is a very weird thing to do with the types, like turning a local pointer into a v pointer because I'm reading my own process. Let's just make this a v pointer, maybe. Time error mem access. Can we just not compare runtime errors? Is that the issue? I don't know if that's the issue or if it's like the reference levels of the string. We should be, I should check whether that has equality. I mean, I could do that with a match, but it seems like it would be useful for these to implement equals if they can. Some of these from types might not support equality comparisons, though. Yeah, I think that's the job for match. No, it'd be really convenient if I could compare those. I don't think that's going to work, though. Yeah. Bunch of stuff inside that can't be tested for equality. I've also seen error types that have methods for stuff like that, like isMem error, something like that, but I don't know if I want to include that in the API just quite yet. Oh, that's an interesting question. Patrick's wondering what the point of map fixed is anyway. Why care about the address? Do you mean in general or in this specific case? In general, there's a bunch of reasons why you might need to care about the address. Like, you might be trying to put something in a specific place in memory, either because a program was linked to assume that something's at that address, or because you want to replace something that you've previously allocated. You might be trying to do like an opportunistic resize in place, where if there's enough address space, you'd want to keep the same address, otherwise you'd move it. Consecutive, okay, what's the point in general? Okay, both apparently. So yeah, like some other places where I'm using a map fixed would be, for example, if you're loading a process into memory, like the process is linked with specific addresses, you know, unless it's fully position independent code, you do have to map it at specific places. The thing that I was just doing is I specifically wanted to replace part of an existing mapping. So, sorry, process. So here I'm using fixed because I specifically wanted to replace the first part of this mapping with a read-write portion. So here I'm just mapping basically guard pages over the whole thing, and then replacing the first section of that with read-write. So you could do the same thing with mprotect. It doesn't really matter. gosh, we don't need 13-year-olds trying to start editor flame wars in here, thanks. Yeah, so in this case, I mmap once without fixed to get an address somewhere that's the kernel's choice, and then I use fixed to replace part of that. There are a bunch of different ways to do this. This is just the one that I decided to use because it came naturally to me. But like, yeah, you could use mprotect. I don't think it super matters. Like, unless you're trying to keep the contents of the pages. Like, this will replace those anonymous pages with new anonymous pages. But in this case, that totally doesn't matter. All right, I was just trying to compare stuff. I'm just going to unwrap these. Let's try, fuck, what am I going to call that? Fine. Can I can't make anonymous type parameters, can I? Part of the problem with this is this is not going to give me line number information. Like, if I cared slightly more, I'd make that a macro, but I don't know that I care, because this is just one little test case. Could also just change this to return a bool. Oops. Patrick's wondering if I'm re-mapping that region without previously unmapping it. Yes, that definitely works on Linux. I would be surprised if that was breaking on any POSIX system, but I don't. Like, last time I looked at the macOS memory management code, it was like held together with toothpicks and string, so I'm not extremely surprised. Hmm. Hmm. Do some more printf debugging. And this looks like my guard page just isn't working. Oh, I don't already have a way to debug my maps from inside the test, do I? I have the whole standard library, though. Yeah, read to string. Oh, interesting. Patrick's saying they're seeing intermittent failures with trying to remap memory on macOS. I mean, yeah, that's pretty weird. Oh. Still no Tuco. He's probably found a great warm spot on the opposite side of the house. He's usually in the same spot, so I might actually find a way to get a camera on there. Build. Maps. $210, 4,000. So there's my read-write map. There's my guard. It does seem like I'm reading from the beginning of what should be an inaccessible page. Let's see if that's a problem with error reporting or a fence post bug. Let's try adding not even just one, but let's add it like a couple of cache lines to that just to get firmly into the very middle of that page. Because if this still doesn't fail, then we're looking at just like an error reporting problem. Oh, so I only want to build this test. -lib is what I wanted. That's much faster. This might just be an error reporting problem. Oh. That's weird. This is pretty annoying. I'm going to have to dig slightly deeper, but I wonder if the kernel is actually not reporting failures on read at all. I mean, it's not the end of the world if it's not possible to segfault by reading on a... I mean, it wouldn't segfault, but like normally if you pass a bad pointer to a system call, the system call fails with efault. But if it just returns zeros, then it's just going to give me the wrong error code, but it's not that big of a deal. I think that's in proc task MMU. Let's look around. Okay, so this is the kernel code path we should be on, memrw. We're doing this one page at a time. This... Sure seems like it should be capable of giving us an efault. Oh, right. So actually, I'm getting confused again. So memrw is an implementation of read. So in this case, copy to user, copy from user. That's going to be for the parameter for read. So actually, the case I'm on here is inside access remote VM. Something is failing. So that's interesting that will never actually give me an efault. I don't think that matters because, I mean, I'm converting the errors into efault. Access remote VM. Yeah, same underlying call that ptrace uses, I assume. This is how we write to process memory, but not how we read. So that wrapper doesn't really do much. I'm wondering if this is actually an issue with the protection flags not applying here. Like, I could try using empty space as a guard page, but that's not reliable since another thread could swoop in and allocate that. I could try making a one-page large hole, which would be kind of unlikely for anyone to fill. Yeah, where did get user page flags come from? Oh, yeah. That force flag might be relevant. Because normally this is used for implementing a debugger, in which case you probably don't want the program that you're debugging to be able to prevent you from reading its memory necessarily. Like, not necessarily for security reasons, but just because that would be inconvenient. Let's look closer at that. Anyway, yeah. Without permission. Interesting. Yeah, so I don't know that that really has any practical bearing to this implementation, but it does mean that my test case has to work differently. And I think I just need to make a hole in memory, and is there a way I can put something else there that the kernel definitely won't be able to read or write? Like, I could mmap something that no longer exists. I mean, yeah, I could do something where I make a temporary file and mmap it and then truncate the temporary file so that I end up with some address space that's taken up but can't actually be read or written. I don't know if that's going to be more or less annoying, though. Let's just try making a hole. Let's do some hole making. Parentheses everywhere. Gosh, strace actually made for some pretty okay debugging just there. Might leave these in for a minute longer though. Oh, I just wanted the test cases to know. Oh, fine. You're asking how long I've been awake. Too long. Yeah, I had trouble sleeping and I got up really early for randomly no reason. I've been up since like 4 a.m. Oh, did that test succeed? Am I running the right tests? It looks like that test passed. I mean, my goal is to make a test that failed, but that's a good start, is having a test that passes. Let's make it pass, and then fail, and then pass again. Okay, so just testing some edge cases around my memory hole, but it's still all zeros right now. Okay. Now test the test. Yeah, that's basically what I'm doing. It's all tests all the way down. Like, I still have not reproduced the actual problem that I'm trying to fix, so I'm still kind of working my way there. What do I expect readString to do if it reads part of a string and then hits a fault while it's still trying to find the null? I think I expect it to return an entire fault. Yeah. Tempted at this point to go look a little closer at that failure and try to figure out the exact alignment I was dealing with. I think we just start by putting anything in there that's bigger than, or not even bigger than a page, but just, I could just splat the same small string over and over again at different offsets, maybe, as a first test. Like, dreading actually writing to this memory. Like, kind of, actually, now that I'm done with the memory holes, it might be nicer to do the rest of the test using using some memory that I just allocate like normal from Rust. I'm going to be annoyed if most of this file is test cases. I tend to want to split stuff up if it gets to that point. I think I can just make a mutable byte slice and do what I want with that. This is like the unsafest of unsafe. Because part of this slice is actually unmapped memory at this point. Nested unsafes, yeah, basically. I mean, I'm curious, like, what is my actual count of how much unsafe I've got in here? So this is the low-level code. How about the high-level code? Quite a difference. Right, like some of these I just added. Some of them are in test cases. Yeah, but except for the stuff I'm adding in the test case right now, most of this unsafe code is not really that unsafe. It's mostly just libc stuff. Whereas some of the unsafe code up here in the low-level runtime is like really unsafe. Like we're just assembling pointers and making system calls and whatever. There's probably some cleanup work I can do to limit the extent of some of that. But there's also stuff like this, like these 3 unsafe blocks. The reason those are unsafe is because this requires that the input is null terminated. So if I had some other type guarantee that I could make about like C null terminated strings, like there's a library for that in standard land. I just haven't looked at the no standard options for that. Most of my unsafe blocks though are because I'm making system calls. So it's like that, like poke data. Could you get more unsafe than ptrace poke data? Syscall fork, right? Syscall fork is always going to be unsafe. This test plays danger zone when it runs, right? Highway to the danger zone. I have some weird memory as a kid of having like a tiny like answering machine sized microcassette player that I got at a thrift store or something, and or had that song on it for some reason. And the speed would always be a little messed up. Like, I think it was intended for dictation, so the speed, like, it wasn't really music quality, and it had some like long play modes, and you could like mess with the switch and get it to play at the wrong speed, and or play at like indeterminate speeds. ptrace rmrf/. Yeah. Luckily, we don't have a real file system. All right. I just want to make up some junk that'll be relatively consistent junk. I don't even super think it needs to be like... Actually, why is this a string anyway? Because I'm using the version of this that... I don't super want to test the UTF-8 parts of it in this particular test case. So like I could bypass that entirely. I think I'm just going to make a string that's pretty simple though. Like... Do I have a convenient random number generator? Yes, I do. Let's just use that same one. I'm just going to use the default thread random for that. There are so many ways this could fail. This would not be Something to rely on outside of a test case. But in this case, if it fails, I just get more information about how it could fail after debugging it. It feels slightly safer to have this slice reference only exist for a limited period of time, but I'm feeling a little lazy about that right now. Let's see if that works at all. Oh yeah. Like, this basically breaks Rust aliasing rules because this is sort of like an immutable reference, sort of. And this is definitely a mutable reference. Oh, right. From raw parts mute to the even more unsafe function. Ooh, truncation. Oh, no, even better. That's an extra 0. So the test string is on the left side, the readback is on the right side. So I don't know if this is exactly the same failure, but it's looking really similar already, where we've got a longer string than we expected. And it's at the end of a page. These errors are okay. Yeah, I'm fairly convinced that that's the same bug. Now it's probably time to look a little closer at it. Let's make that string slightly more complicated. Yeah, interesting. Okay, so now looking closer at read string OS. So we're hitting this case where page remaining is smaller than the string we're reading. What's this iter position doing again? That's searching for an element. Right, okay, so we're searching for the null terminator. All the cases that succeed have been on this path, just finding the null terminator in the first read. So we're on this path, we're accumulating stuff into our buffer there. That doesn't seem right. So let's first of all just simplify this, like, and this is looking like an off by 1, but we were definitely getting overlaps of multiple characters in the other test. Oh. That's weird. These are failing way earlier in the page than I was expecting. What's going on here? Let's just add more debug print. Or at least the problem is easy to reproduce here. Oh, cool. There's a comment in chat that I've convinced someone to start experimenting with Rust. That's cool. Yeah, I find Rust really nice. Like, I mean, I've got no, no stake in the project really. I just enjoy it. Like I've felt like Rust was a pretty nice, enjoyable language for a long time, but this is definitely the deepest I've gotten into it. Um, the other project I was using Rust for was part of the Tuco flyer was written in Rust, but not the whole thing. I did the microcontroller firmware for that one in C++, mostly because I was using some libraries that were already there in C++, and the libraries were much more significant than the code that I was writing for that part of the project. And I wrote an OBS plugin in C++, but then the actual like main part of the robot daemon was written in Rust. Oh, semicolon. This is super weird. Yeah, the live data in the Tuca flyer was pretty cool. It was fun making a little web thing for that using WebSockets and making some nice squeaky graphs that just track the robot in real time. That was pretty cool. This keeps getting weirder. All the places that I expect to find this problem, it's not there. Like, I don't think it was a problem with any of my pointer calculations or whatever, and now, like, I'm calling read bytes here, and it's in that result. So, like, and then read bytes is basically just memfile read exact at, and this isn't even my code. This is part of the standard library. And I mean, it just turns into one system call. We could look closer with strace, but like this is just pread. Oh. No, this is a problem with the test case. So this number changes size. I'm not explicitly adding the null terminator. So far I've been relying on the data or the memory to already be zeroed. So yeah, this is just a problem with my test case. I just need to put an explicit 0 in here. Can I do that? Okay, so that's... Getting low tech here. Oh, that's another question about whether Tuco Flyer will come back. Maybe. Yeah, I was saying earlier that this the space I have is much smaller, and it seemed like it wouldn't be super practical here, but maybe there's a way to make it work. Okay, is this actually the other failure now? Or is this another problem with my test case? So more debugging. I feel like this would be easier to debug if I used a test string that didn't keep changing sizes. Let's just pad the heck out of this. I don't know, I like it when the string changes sizes from a sort of test chaos perspective, like just doing things that are different from each other so that I catch more problems, but it does make this a little harder to debug. Alright, so now they're decreasing by 1 byte every time. And it looks like the last successful one here is when the read is perfectly aligned with the end of a page. And then the first unsuccessful one, I assume, is the one where the null terminator is the first byte of the next page. That seems to be what's going on, is the null terminator is the first byte of the second page, and instead of ending the string here, we end up with a duplicate. Why is that actually happening? So in this case, we go through this loop once, we hit this case once, we're copying this buffer into the result, advancing this by exactly 1 page length. Then we come around again. Oh! Okay, yeah, no, I totally just did not see this other copy of the push down here. We are literally just pushing it into the buffer twice. So, probably could have determined that just by looking at this code a little harder, but it was nice to work through that bit by bit and actually find the problem methodically. And now I know that I've got a test case that finds it. So that's probably it. That was probably the whole problem. So far, so good. Can we make this test case more complete? Let's have strings that are bigger than a page. Can I just have these both? I mean, I don't want to make this like the full Cartesian product of all this, but let's just have a list of a couple of test strings here. thinking about the easiest bad way to generate just test data for this. I kind of want to just glue together random numbers until I get to the right length. This is kind of gross, but it's just a test case. Hmm. I don't think extend is the right function there. Oh, is push stir what I want? Yeah. I feel like I probably don't need to explicitly as stir that. Nope. Fine. I guess that doesn't really do anything easier than just doing that. Oh, is that a passing test? It's a slow passing test. I do actually kind of want to test all the offsets. Maybe we can just trim some of these. Right. I guess that doesn't need to be mutable because that's... I mean, it's already a mutable reference, and it doesn't need to be... Like, that reference doesn't need to be an immutable location if we're not taking additional mutable references, I think. I think that's what's going on. It's a little slow, but maybe we can deal with that. Let's run all the tests. There's a question, is this Vim? Sort of. It's actually Emacs, but it's sort of pretending to be Vim. I feel like the answer to is it Emacs and is it Vim are both yes at this point. Okay, well that was a nice little detour. I need to clean up the mess I made, but I think we just fixed a bug at least. The actual bug in this case was just literally an extra line of code at the bottom of this loop. But now there's a test case that'll catch stuff like that. Ooh, what was that? Oh, these are all failing because my output is polluted. That's fine, I can fix that. There's a comment from somebody who's glad they stick to high-level languages. I can understand that sentiment, but I kind of feel exactly the opposite. I feel like when I'm programming in a very high-level language, it's easy to feel very much like there are just so many layers between what you're writing and what the computer is doing that it can be kind of hard to visualize what's going on. Whereas in languages that have more of a predictable interface to the underlying machine, I feel like those can be nicer to deal with sometimes. Like when you write code in JavaScript, it may feel simpler than Rust, but like when you're thinking about what's going on at a different level, it's significantly more complicated. And so it kind of depends on like what your point of view is. Rust is also not a simple language. It's not as complicated as C++, but like Rust is not trying to be a relatively minimal language in the way that Python is. Rust is trying to just kind of be a useful language. So it has a lot of features that are specifically for solving problems that systems programmers often have. This seems like it might be working. Okay. So this is with a bunch of changes. Like I changed the way that process memory is allocated, and we just made a change to the string reader, and these are all still working. So I think the next thing to do is to actually set up that the generic allocator. Oh, there's a question about whether I ever mess with Lua. Yeah, Lua's great. I've done more like writing programs that embed Lua than writing Lua, but I think they're both pretty cool. The main thing I did like lots of Lua programming for was this project that's actually open source now, but wasn't when I was first writing it. So yeah, this is the software that ran these little cubes a while ago. And Lua is used in a couple places. This asset preparation tool called Stir uses Lua scripts in kind of a trivial way just to set up graphics and sound. The more significant place is that this emulator is scriptable in Lua, and that's actually how a lot of my internal unit tests were written, is by scripting the emulator. So I think a lot of the stuff in this directory is written in Lua. So yeah, we've got some Lua code. Has some infrastructure for debugging the file system. Yeah, it could do like screenshot comparisons, and it could do low-level file system access. Where are the actual unit tests? Ooh, RF spectrum. Yeah, most of the interesting tests were for the Cube firmware. This was Lua code in the emulator testing the firmware that would normally run on a little 8-bit processor that just didn't have any space to spare for a testing framework internally. But this was also kind of testing the emulator itself and also testing the hardware design, so there was just kind of a lot going on here. I'll be right back. I wonder if I can get Tuco's attention. Oh, he looks very asleep. No, he's kind of awake. He's just really comfortable. This water bottle is quite transparent in the green light. Burr. I should keep an eye on my continuous integration. Oh yeah, this stream is mostly about Rust programming, but someone was asking about Lua, so I was just briefly visiting an old Lua project of mine. I wonder if anybody's done a Lua interpreter written in Rust. That would be a funny project, right? I mean, Lua is a very simple language. The interpreter, at least last time I looked at it, the one written in C is only a couple thousand lines of code. So we've got bindings. Like, I don't know that there's a huge reason to rewrite Lua in Rust, because Lua is pretty well written as far as C code goes. But it would be kind of a funny project, I guess. I mean, I know a lot of folks are down on low-level languages, but, I mean, consider the kinds of things that they let you do. Like, you couldn't write like a lot of interesting operating systems or graphics code if you only had high-level languages. Like, how would you decompress video? How would you write your own compression codecs and run them in a reasonable amount of time? There's a comment that something on, I guess, Lua for the PlayStation Portable could render 3D. That's interesting. I mean, the scripting language that you write, like, I mean, big enough processor and you can write a software renderer on pretty much anything. Like, it used to be folks were really surprised seeing software rasterizers written in JavaScript, and now that's, like, seems pretty everyday for people to mess with. Oh yeah, and then there's also a comment about WebAssembly. Yeah, Rust is really good for WebAssembly. I mean, in general, like in a WebAssembly environment, what you want a lot of the time is a way to write code that is pretty performance focused, because that's a lot of the time why you want WebAssembly in the first place. But then you also want it to be fairly small and easy to be self-contained, because that's the environment you've got with WebAssembly. And so there's a pretty nice set of libraries to help Rust fill that niche. There's a comment that says bad libraries. You mean for Lua? Or something else? Someone made a JavaScript MPEG-1 decoder. Yeah. Yep, they did. I used to be more into the, like, stunt programming kind of things like that than I currently am. Nowadays it's more like, yep, that's the thing that exists. Why does anyone care? I mean, it is kind of an interesting, like, programming curiosity sometimes. I'm sorry, there's an urgent, really good picture of a dog that I have to respond to. Anyway. Oh, did I not push that? I guess I was going to push it after the tests succeeded. Be slightly responsible. All right, switch gears slightly. Actually, I want alloc. Oh, the comment about bad libraries was if you were doing video decompression in high-level languages. Yeah, I mean, you can, like, Turing completeness is a thing, right? Like, you could write whatever program you want. It's just not always going to be, like, fast enough or easy to deploy enough or reliable enough for it to be usable, depending on what you write it in. That said, I mean, I've said this before, like, this is like a better time for writing programs in basically whatever language you want to than has ever existed. Computers are fast. People are used to downloading kind of software that's already in some kind of container, so it's pretty easy to just deploy stuff written in whatever language if you don't have like unusual constraints. I think I'm just going to add an implementation of this to my little nolibc library, which maybe someday I'll turn into a separate crate, but right now it's just a module inside my sand. Okay, so back to the memory allocation issue. So here's nolibc, where I've got a very basic alloc and free that just do page-aligned anonymous memory with mmap. Right now I'm using that just in one place. So I'm allocating a process and freeing the process. And this kind of works. It's just really insufficient for what I need. As I was saying earlier, I need the ability to allocate and share file descriptor tables, and like an entire table of file descriptors is large enough that I don't think I can just keep them inline in some kind of monolithic process table like I was using. So it seems to make sense to keep a lot of stuff grouped together like as much as possible, like generally have large objects that map directly to page allocations, or to allocations of multiple pages with mmap. But maybe I have one of those allocations per process, just in general, and then maybe another individual allocation for things that are often per process but can be shared, like the file descriptor tables. Like another point in this design space is just to go all the way to having a full-featured allocator. I was looking into that a little bit. It would be kind of cool if there was just a fairly simple and easy to reason about and easy to secure kind of like hopefully pure Rust implementation of an allocator. It seems like the main allocators people are using are Rust wrappers around C libraries. I actually haven't looked at this one because I was like, oh, I don't need a WASM thing, but maybe it's not specific to WASM. Okay. Interesting. What are the design trade-offs here? I don't think I care about small allocations. Like I should really put some logging in this if I go this route, but I expect that most of my allocations will be in the like 10 kilobyte sort of range. Oh, that's a good question from one who asks, is the Rust allocator not written in Rust? That is a very good question. I thought the Rust allocator was using slightly-alloc, but let's see if we can find that. I thought Rust's standard library had its own memory allocator rather than using libc, but maybe it uses libc directly. I'm not sure if this is the default allocator. This allocator is definitely just a malloc wrapper. Might be quickest just to look at the source code. Oh, syscommon-alloc might be it. Oh, here's the global allocators. Maybe it is just using the system malloc. You know, I sure thought Rust had its own malloc, but maybe that's old. Like, I think that might have been something that changed a while ago. Oh no, JE malloc. Interesting. Are we linking with it and then using libc to reach JE malloc, or is this an old comment? Maybe libc has some comments about that, actually. No. That's a good question. Z1's asking what would be a reason for the allocator to not be Rust code. Mostly just because an allocator is actually a fairly complex and difficult to tune piece of software, and there isn't much to gain from rewriting it in Rust. So if there's already a really good, robust implementation of an allocator in C, then people are going to use that. Like, there isn't really any overhead to interface between Rust and C code. Like, they can use the same binary interface. So the only reason to rewrite it in Rust is if you wanted to try to write something that's easier to verify that it's safe, or easy to verify that it's correct. But like, a lot of the problems that you're solving in an allocator are not necessarily things that Rust's type system give you that much help for. Like, you might be able to write a nicer, safer allocator like that in Rust. That's kind of why I was looking for one. But it's also not totally surprising to me that, like, if that hasn't been done, because allocators are like very fiddly pieces of software to write and tune. So like, this JEM allocator, for example, is like a wrapper around the C code. Same with this. Like, those are just different layers of the wrapper. I think this is what I was thinking about. Okay, yeah, so I guess that was removed at around the same time that they added the kind of pluggable global allocator trait. So they still use JEmalloc in Rust and in LLVM. Interesting. That's pretty cool. Like, I haven't actually looked that closely at JEmalloc. So based on the FreeBSD libc, predictable behavior, and it's still maintained as part of FreeBSD. Gosh, I feel like memory allocation is actually one of the more interesting parts about learning to program. Like, you can go through an entire career of programming computers without ever really having to examine how memory allocation works. But where's the fun in that? I feel like if you go straight for understanding how memory allocation works and like why all these different trade-offs exist, you'll just be headed straight toward the juiciest part of learning, like how to make computers go. That feels nice to me. Yeah, this is something that people have been tuning for performance for a long time. There's a lot going on here. This is not what I want for my particular use case right now, but I'm glad this exists. I was going to take a very quick look at this, but I still think that I'm probably headed toward writing an extremely bare bones allocator that just passes each allocation directly to mmap and then use it very sparingly. I don't know why anybody thinks that it would be relevant to the chat that they don't like Rust, but thanks for sharing. Let's take another half a look at that wee malloc. What are you talking about? It embeds a lib to print to standard out? I don't know what language you're even talking about or what library you're talking about. If you're complaining about Rust needing library code for standard out, I mean, that's like every language has a standard out library. You could use the system calls directly, but there's generally a reason not to. And in fact, like, if you're going to complain about a language having built-in libraries, I don't know why you would choose Rust, because it's possible to disable just about everything in Rust. So, cool story, bro, but I don't quite understand what the complaints are about. This is maybe the closest thing I've seen to just like a real kind of normal allocator algorithm that's written in pure Rust. But this is definitely like intended to be small rather than intended to be like especially general purpose. That's also interesting. We never free pages. Yeah. Meh. Wait, why is global alloc in core? Why is there a core alloc? That's interesting. So I guess the core library defines the interface necessary for the allocator, but it doesn't define data structures that need the allocator, if I understand this. To implement allocators for core. Yeah, I mean, the whole thing about core is that generally the core library does not depend on memory allocation. So stuff that would go in core, except it does depend on memory allocation, goes in alloc. So the existence of a core alloc feels a little weird to me, but I think this is just for the interfaces, not the stuff that actually depends on them. Right, like these functions were not in core alloc. One, they're not stubs. There are no stub functions in there. Those are traits. Like that. It's funny when the people who have the most complaints are also the people who have the most wrong assumptions about what's going on. Yeah, that's nice. Just a plain old alloc. Don't mind me. That size and align. It's probably worth asserting that align is smaller than page size, but that's all I'm going to do with that. This file's getting a little big. I feel like these, I have no reason to expose these if I'm making a full-on global allocator. I think I've got to put unsafe here too. I need to go look back at that failure function. I think I do actually want to implement all of these, even alloc zeroed. So because this is mmap, it's actually always going to be zeroed. So I can just forward this to that. I should also check that it's a power of 2, but I don't think we care. Oh yeah, this already has preconditions that must be a power of 2 and non-zero. Cool. Yeah, I guess I can keep this only depending on core if it's just implementing the allocator and not installing it or using it. Is this in core and alloc or just alloc? Okay, that's weird. So this is for the client, not for the allocator implementation. We do just return null here. Okay. Sorry. Yeah, I want may move. Oh, and new address is actually optional. That's great. This is a new API, man. I've generally not been just adding constants that I don't really have a use for. I've been trying to keep API relatively pruned. So let's just put may move in there only. I think the return value is just the same as for mmap. Let's see if that compiles. So far so good. Oh. Cool. Okay, let's try actually setting this as a global allocator, maybe. Yeah, something like that. Oh, what am I doing? Sand, no ellipse, or no, just page allocator. Okay, and then the next step is to make table use a regular Rust box for this. Can I box pin process? Or no, pin is a type of box. I think. Maybe I'm confusing myself. Oh, this is what I was thinking of. Yeah, a pin is not a type of box, but a pin box is a common thing to assemble this way. And I can start out with a regular box, allocate the thing directly on the heap. So before I was using pointers for this, I was using a vec of options. I noticed a crate recently that seems like it might be useful for some of this. It's called slab. It's basically the same concept I'm going for. It's pretty popular. I don't know if this key is opaque or not. That would be worth knowing. So this is like almost maybe something I could use as a process allocator. I'm wondering if the range of allowed keys is specified. I'm assuming that a key of 0 is valid. Yeah, I don't know if that actually makes anything simpler though. Let's make this a vec option pin box of process. It's a bit of a type, isn't it? I have to explicitly import alloc somehow, don't I? No, I guess I just have to ask for it with extra and crate. Hmm. Oh. I don't know if there's actually a cleaner way of growing that table than just looping over push. The resize is nice, but this type is not actually copy. This is tickling my annoyance about the placement new thing, but I should try to just not have individual values that are that large. I think I can pin this right away. Oh yeah, I can construct it as pinned. That's what I want. There's no way to guarantee this won't move at once at construction. It just means that after it's pinned, it won't be moved. Don't really have a way of testing this process removal stuff for the most part. I do actually try to clean up the process when it exits, but I'm currently not running containers with multiple processes or processes kind of dynamically coming and going yet. Pretty soon though. Sorry. Okay, I've got an option pin box. Where do I get intermutability? Like, do I need a cell for this also? I think that's what I want. Like, I don't think I need intermutability here. I think I'm just using a mutable reference to the process table to get a mutable reference. But that's the thing, like or is it? Like, I don't care if the box is mutable. I want the contents of the box to be mutable. But because I'm not setting up an intermutability cell, it's just going to be both, I think. I think this is actually what I want. This might be easier to understand without the map and flatten. Let's just try writing this without the map. I think it might be a little easier to reason about. Oh. That's not what I need, but that's interesting. could bring that into scope, but I think I don't need to. I thought I could do a mutable index implicitly, but maybe I have to... The other syntax I thought worked was something like this, but I could be wrong about that. Does that work if I import index mute? It's like the same problem. I don't know what happened to the option. Like, this is just asking, like, or acting like it's trying to dereference the contents of the option. Oh. Is this an issue with standard box versus alloc box? Is there a different version of pin in alloc? That would be weird. Oh, I know it is on an option. That's interesting. Maybe I can do it without that. I feel like this might be some weird standard versus alloc compatibility thing, but maybe I'm just doing something wrong and I don't understand. That looks like it's not doing anything, but actually I'm making a new option here with the reference inside of it rather than outside. Oh. So now we're borrowing from the table instead of moving it out. We're doing that just long enough to look at the syspid and remove the corresponding virtual to system PID mapping. And this actually deallocates it when we write over with null or with none. Oh. Unnecessary, unsafe. Right. Oh, mremap should be unsafe. Oh, that's right. So like these are already unsafe. I'm literally doing the nested unsafe block thing. Oh yeah, so a lot of this stuff still works because the process, like the box, is transparent to most like method calls and other kinds of dereferences. But I'm seeing little things like that change. So this is now a pinned box, so it's pretty much exactly what I expect here. That'll always succeed. Oh, this returns the item. Interesting. I think unwrap was failing before because there was no way to format the error type on failure. Because it wasn't really using a normal error type, it was using that as a way to return the value. Anyway, the low-level tests are passing and it compiles. Let's try the higher level tests. Ooh. Default alloc error handler. That's new. This is new to me. Why am I on Google? Thought I'd switched it here. Maybe not. Anyway, alloc error handler, right? Cool. That's actually kind of nice because then I can add a special return code just for out of memory. So I should just copy the signature for this. Oh, right, protocol. Did I decide that an exit code was a message or a type? Is an exit code a sandwich? An exit code apparently is not a sandwich. Oh, there's a question about the editor here. This is not like this is not part of Rust. This is just Emacs running some Rust modes. I don't think Rust has an official IDE, but it has support in plenty of popular IDEs. So if you use Sublime Text or VS Code or I don't know what else do the kids use these days. Atom, I think those all support it just fine. There's I forget whose standard it is. One of the editors has a standard for language servers that implement like dynamic support for like auto completions and symbol lookups and stuff, and Rust has support for that. So yeah, I've never used VS Code, but I hear it works pretty well with Rust. I've used Atom a little bit. I've used Sublime Text plenty. I've been pretty into Doom Emacs lately, but you know, I won't start a fight over editors. Let's just start with this. I feel like I do actually kind of want to use that same panic message. That's a good question. Arnie is wondering how come most of the things in this file are marked config not test. That is because most of the stuff in here is not useful when I'm compiling the unit tests, because the unit tests do use the standard library. But when I'm compiling it without unit tests, it doesn't use the standard library. And it might be worth making a submodule in here that's marked config not test, and then stick everything except main in there. In fact, I don't really see any downside to doing that, since I think everything in here except for main, well, like everything in here really, including main, is only referred to from outside of the project. So like main, language items, panic handlers, stuff that the startup code calls. So none of it really cares about where it is in the Rust module space. I think I can just call that main no standard. That would also let me clean up some of these. I'd been avoiding putting a bunch of uses in here because they would just turn into dead code in test mode, but if I do it like this, I can put as many uses as I want in there. I feel like I could probably use these macros without namespacing them. Let's try that. Let's just do this. See what the compiler tells me. Oh, it's Tuco back. I thought I heard him at the door. Yeah, I can clean this up a little bit, I think. Cmain, C-star V slice. Not your typical startup code. Gosh, life was so much worse in computer programming before languages commonly had namespaces. Like, looking at all this old Linux code is also reminding me just how much they rely on having a single flat namespace for everything. And then a lot of folks faced with that would maybe add some internal namespacing to their naming conventions, but nope, not Linux. It's just free for all. Oh, blast from the past. Jimmy's wondering, they said that I've mentioned Sun-O before, and what other music do I listen to? Gosh, Sun-O is pretty good. I feel like I wouldn't call myself like a fan of them because I don't especially know as much about them, but I think they're pretty good. Gosh, what have I been listening to lately? I haven't been listening to music super regularly lately, but I feel like sometimes I've been I don't know, like every once in a while I get into a mood where I just have to like listen to a bunch of Radiohead or something, but then, I don't know, sometimes I'll listen to pretty random stuff. Oh, there's our exit okay. All the way down there. I should add that exit code on the other side before I forget. How much of this compiles? Oh yeah, that's a pretty easy question. Arnie's wondering if I would be able to explain to a relative OS layman what this custom global allocator does differently than the standard one. And the short answer is that it does way less. Like the standard allocator has a fairly complex job to do where it's trying to fulfill allocations that come in at a variety of different sizes with all sorts of different usage patterns on any thread, and it's got to pool those allocations together in a way that reduces the number of round trips that you make to the operating system kernel to ask for more memory using mmap or break. And you also want to organize those blocks of memory so that you keep things with similar sizes together, and you overall sort of try to manage the amount of fragmentation where you end up with holes in memory that are hard to use because of the places where you put things. So general purpose allocator is actually a pretty complicated job because you've got all those different constraints to balance, and it has to be high performance under a lot of different circumstances for it to be a good allocator. So by default, so that was kind of the thing we were just looking at earlier, is I was trying to figure out like what is the default allocator, and it looks like it used to be this allocator written in C called je-malloc, and now to save space they have it use the default system allocator. But the thing about the default system allocator is it isn't really technically part of the operating system, or at least not part of the operating system kernel. The operating system kernel does usually have its own internal allocator, but kernels often have kind of different memory allocation constraints and different memory usage patterns than a general purpose application. So you often find that kernels use allocators that are tuned more for robustness and simplicity than just sort of raw performance under certain application workloads. So the allocator that I've got here right now, I'm intending to use it very sparingly. So think maybe a couple of allocations per process that you create. So very infrequently. and in contexts where I'm already doing a bunch of other like interaction with the kernel and stuff that I don't expect to be inside of inner loops. So it's really a way to just have some kind of dynamic memory allocation, because I do have a couple of things that I need to dynamically alloc, but without having a dependency on this system allocator, which doesn't actually exist in our current use case. Like there is no just generic allocator in user space. The one that Rust is using is actually part of the C standard library, which I'm opting out of using in this particular place because I'm trying to have I'm trying not to have any dependencies on the particular C standard library that the current Rust toolchain uses. So if I was using the C standard library in this binary, I would either need to specify a particular Rust toolchain with a particular like library, or I would need to make sure that it works on multiple kinds of libraries. And it just seems overall much simpler to just bypass the libc entirely and just make system calls, because the thing that I care about doing here is making specific system calls. So yeah, I mean, maybe that was still kind of verbose, but the short answer is, like, in this particular circumstance, there is no default allocator, so I have to pick something. And the thing that I'm picking is basically the simplest possible thing, which is to pass allocations straight through to mmap. But that's why there's all this like weird bootstrap kind of code in main, because this is running without the benefit of a standard C library. That's not the real main. This main. That's also what this nolibc library that I have in here does. It's a little thing that I wrote that just kind of fills in some of the stuff that I need that would normally be libc's responsibility. Anya's wondering if this will fix some of the seg faults from yesterday. I mean, yes and no. I mean, those seg faults weren't really bugs. Those were just symptoms of the way I was doing something incorrectly. Like I was using the fact that it was crashing as feedback to tell me that my stack was too large, basically. So yeah, I mean, this route that I'm on is basically trying to open up a way to have a few things that are dynamically stored per process. So like the sort of intermediate goal that I have here is that I'm trying to have a way to store file descriptor tables. And I can't just store the file descriptor table completely inline in the process, because there's no way to make it sort of reasonably sized and also reasonably flexible in that case. So I want something where I can have a few big chunky allocations for things like an entire process or an entire file descriptor table, but then within those things are still pretty static. And so I think the seg faults you're talking about were experiments I was doing to try to reduce the amount of stuff that I had on the stack by putting a couple of specific things into mmap sections. And part of the problem I was running into is that there wasn't a good way to allocate that data without moving it more times than was really useful. So I was having trouble making something that was actually had the properties that I wanted, where I can add additional stuff to the per process data structures without blowing up my stack space. And so part of the reason I'm hoping this is better is because I'm actually using Rust's built-in box type instead of trying to do my own thing with raw pointers. I think that might work out a little better, but I have no guarantee. Like, there's no guarantee that I can allocate something at a particular place. So that's also why I've been saying that I need to use this to also just keep the maximum size of a single value relatively manageable. So the largest single value that I'm probably dealing with is something like an entire process or an entire file descriptor table, and I want to keep stuff like that under like a megabyte. Okay, where are we at here? So I have to enable this experimental feature, and why is that unused? Oh, right, that is only for config test. I totally glossed over the like per line conditionals that I had down here. One other difference between the higher level and the lower level code here is the lower level no standard code also requires nightly rust because I'm using some stuff that is not standardized yet, like this alloc error handler. But the higher level code does not require nightly rust. At least I don't think it does. I haven't been testing it super often on stable rust, but it's written to mostly not require that, or to entirely not require that. I just haven't been testing it regularly. So the idea is that you could compile the outer runtime with, say, stable rust and the sand process with nightly rust, but you shouldn't ever have to compile the sand process with a specific libc, because it kind of includes its own bits for that. So if this works properly, I shouldn't see any change, and just all the tests should pass. But nothing should be different. If I had a way to test like fork effectively right now, I could start a shell and then fork some subprocesses and look for individual memory mappings for each of those subprocesses, which might be a nice test to do soon, but I can't easily do that without fork. And fork does not quite work. Fork does not need that much more work, so maybe I can just make fork work. The main reason I hadn't implemented fork, honestly, is that I didn't have a good way to test it because I wasn't getting far enough in loading a process. So it might actually be pretty easy to implement fork. Like most of what it's doing is copying the state of a process, and I don't have a lot of state currently. This looks promising. This is looking great so far. I mean, I don't have a control experiment, so it's hard to say for sure that this is working correctly, but good sign so far. Assuming this passes, I think I might quickly try adding just a big junk array to the process like I was doing before, just to take up some extra space and see if that still works. Oh, I should check on my continuous integration too. I should look into setting up my own CI at some point. I kind of lazily just threw this on GitHub Actions because it's convenient, but I really don't like relying on GitHub. Looks like that was fine. Okay, I'm going to check this in before I mess it up. You know, the simplest way to make my task state larger is actually probably just to put any local variable in any of the async code. Like, actually. I don't know how to be sure that won't be optimized out. I think if I put it in this scope, it'll stay around. Let's try that. Let's just make it big. Big ol' thing. I don't want to run the whole test suite right now. Okay, we're running the shell. It's having its usual set of issues, but nothing unexpected. So here's the sand runtime. Maybe it did get optimized out. I don't see any big mappings. I don't know if there's like a built-in like optimization barrier or something that I can use. I was imagining just passing a pointer to this to a system call or something. Oh, what do I have handy? I mean, I could just print the whole thing, but that would be big. I don't really want that. I'm always forgetting the order of the arguments for everything. There, that won't do anything, but Rust, the compiler, doesn't know that. I can just pull in that macro without importing it. Okay. Oh, that might be it. That's about the right size. Cool. And I think that's where I would expect the mapping to be. It's a little weird that there doesn't seem to be a BSS segment. That's pretty great. That's about what I expected. So it has one copy of that large buffer and then about the right amount of other stuff. So like 10K or so. Well, that's great. So I think this basically just works. And the next step would be actually adding a data type for the file table. So that's cool. This also means like I could use dynamic allocation for other use cases, but like every single dynamic allocation is going to give me a separate memory mapping here. So I do need to use them sparingly. But for large stuff like this, it's pretty much perfect. Like a single Rust box that's like a megabyte. Like that's, yes please, more like that. And this one's only one page. I think that's just shared, or not shared data, but it's like some kind of private zeroed data for the dynamic linker, which is not useful here, but is enabled still. That feels like the best stopping point I'm going to get in a little while. I had this other kind of work in progress change, but I don't think it's quite ready yet. So I was starting to do this thing where I changed the file reply to be a pair of vfile and sysfd. But for this to really be useful, I need to add that fd table. So I think I'm going to implement the fd table first and then stick this in there. And I haven't totally decided what the fd table should be like. I think part of me thinks it would be great if I could, similar to what I'm doing with the process table, basically just pick a static, relatively small size for it and use that as the size for my address space. I don't know that that works, though. I don't think I'm extremely in control over the range of file descriptors here. Like, I mean, I could always turn down the U limit or whatever, but like, I'm not actually the one allocating file descriptors. So if I'm tracking file descriptors in a small fixed size array, or any fixed size array really, and the kernel gives me a file descriptor that doesn't fit in there, then I've got to do something. Like I could just bail on the entire process, but I'm just like thinking about whether there's a better architecture, and maybe I want to use like a hash table. There's a fixed size hash table data type that I've been using for some stuff, and I might use more of that. So I could use a little fixed size hash table to go from an operating system file descriptor to a virtual file inode. That's basically exactly what I'm already doing for system process IDs, so maybe that is the right option. That's in this other thing here. Yeah, I'm using fnv index map. fnv is just the type of hash function. Like mostly this is, the important thing is that this is from the heapless crate. Oh hey Tuco, is it time for cat? Is it very time for cat? Cat. Do you just want to talk to folks before I finish the stream? Oh, he's licking me and it's so cute and it's slightly off camera. Oh gosh, it's been over 6 hours already. Gosh, this cat is so good. Hmm? You wanna climb me and yawn. And nuzzle wires. Aw. You wanna check out the outdoors again? It's so cold. I'm cold just thinking about it. Oh, now I'm feeling cold. Tuco, why do you like this? Oh, let's both be done with that. Thanks, Tuke. I like that 44 Anonymous says, finally the cat video I came for. YouTube served me a really long ad for Rust. Just doing the Rust Foundation's work for them over here for free. Is this gonna work, Tuco? Are we gonna do a running or not? No, you're just coming back over here now. Indecisive cat. What are you doing? Brr. Various coldnesses. Significant and various coldnesses. Mostly coming from the outdoors. Again? Or two? Look at all that green. Oh, that's a good question about the star of the show. Somebody wants to know what kind of cat Tuco is. He's a great cat. He's pretty all right. That's usually what I'm thinking about. I mean, I think he's also an American curl, and he's polydactyl, and he's part Bengal. You can see his thumbs there. He's going after the fresh catnip. It is meow o'clock. Yeah, I think I should probably stretch my legs and play with the cat a little bit, but we can hang out with Tuke as long as he's cooperating with the camera before I shut things down here. Well, thanks so much for hanging out, folks. if you want to check out the code for today's project, there's scanlime/bandsocks on GitHub. I'll put it up here really briefly. This one. Go back to the cat where it's important, right? Yeah, and you can find some links up there on the top of the screen too if you haven't noticed already. There's streams and VODs on Twitch and YouTube, and VODs on Diode Zone. And thanks so much to my patrons. The folks supporting the show on Patreon help me keep doing this often. I'm trying to actually give myself a kick in the pants to stream regularly, especially now that I've got a project that seems to be in full swing. So I don't currently quite have an actual schedule, but if you want to get notified when I'm doing these, I've got a Twitter bot set up at Scanlime Live, and you can also use the regular notification thingos on Twitch and YouTube. Oh, Took. Yeah, sorry if it's been hard to catch my streams. I know my schedule is pretty unpredictable, and I'm trying to work on that, but I'm also trying to just do this more often, so hopefully the luck works out and we can be online at the same time. I can use the wheel if the star doesn't feel like it. Right. If it was slightly bigger, I'd probably be able to run in it. That would be neat. Oh yeah, there's a comment that Tuco has interesting ears. Yeah, that comes from his American curl parts. So yeah, I think his breed is roughly half American curl and half Bengal, or at least that's what I was told. And so he gets a lot of his personality from each of those. Like Bengal cats are pretty high energy, and then American curls also tend to be a bit more like kittens all the way into adulthood, like very playful and energetic. So Tuco's got a lot of that going on. Because he still acts like a pretty young cat. He's almost 8 years old. I'm actually bad with birthdays. I should know exactly how old he is. Aw. Good cat. See, I want to get out of the way, but if I move too much, then Tuco's going to move. Because he's here mostly because I'm here. He's so soft. Hmm? Yeah? More of that. Oh, back to standing on the fiber optic converter. Wander, wander, wander. Yeah, some kind of remote control gimbal for this would be pretty cool, right? Cleaning mode. Oh yeah, also before I sign off, I should tell folks to check out Diode Zone if you haven't seen it recently. It's an instance of PeerTube, which is a decentralized video site, but basically it's a way to have a video site that is smaller than the entire internet. So if you want a place to hang out and post video and watch video that is not the entire internet and is smaller than something like YouTube or Twitch, and where you could actually like send a message directly to the administrator if you wanted, Diode Zone might be interesting. It's just diode.zone. Man, I've got so many people with this great idea that I should just build an automated robot to follow Tuco. Maybe I should do that one of these days. Gosh. The ceiling in this room is significantly different than my previous ceiling. Like there's a ceiling fan. Like what's even going on here? How far out can I zoom? So that's the maximum zoom out here. So I've got a green screen, a ceiling. The ceiling is largely blank. Then I've got a ceiling fan. Oh, there's a cool spider over there. This is different than the spider I was talking about earlier. I have multiple cool spiders in this room. Aren't I lucky? This is the one I should just have a dedicated camera for, because he's pretty much always over here. Well, the multiple of them. There's actually been a whole family of these long ones. So there were some over there, and then I thought there were some in this corner. Yeah. There's a couple little ones. The big one's over here. And then I thought I saw another cool spider over here. So the other side of the room, you don't see this side that much, but let's see, I've got a calendar and a laptop and pills and coffee, all the usual human things. That's this camera. And it's my screens. And the keyboardiness. But yeah, I could put the winches in the corners of the room, maybe. There's just not a whole lot of ceiling space free here. This is a much smaller filming location than the previous spot that I had. 'Cause this is basically just a small bedroom. Like, I think it's 10 by 10 feet or something. And I can do pretty much whatever I want to it, but it is a limited amount of space. I've also got room for some filming stuff in the garage if we want to go that way. It's close enough that I can run SDI cable out there if I wanted, and I've already got gigabit network in the garage. Like, having fast network means that I can do video, just not video that I super trust to be low latency. Although I've been meaning to try out like that NDI video streaming stuff, since it seems like they've actually managed to do some fairly widely compatible low latency stuff over Ethernet. But I like having a dedicated wire for video when I can manage that. I've been mostly using SDI for stuff. Oh, there's a good suggestion that I should consider a heated blanket or a heated bed for when Tuco goes outside. Yeah, I mean, Tuco doesn't even seem to be super interested in like being fully outside. We've done that a handful of times, but I think he's more interested in looking out the window than he is in actually being outside most of the time. But actually, that blue thing he's sitting on is heated, so yeah, he's definitely all over the heated blankets. I've got two of those little blue pads for him. I've got one here and one roughly on the opposite end of the house, and that's when he's been off camera today, he's been mostly on that other heated pad. So he's really into those. I kind of want one big enough for a human at this point. Usually when I'm in here and I'm not streaming, I've got like a blanket over there that I can hang out with. Like, I've got my nest of junk and blankets and keyboards and stuff over there. Woo. That's always fun, right? A little harder to do this on a tripod. Ah, thanks, image stabilization lens. Oh, interesting. The Yeti says that maybe one of the spiders up there had a shed skin and frame too. That is certainly possible. Like a bunch of those have been hanging out up there for a while, and it's possible that some of the pieces that I thought might have been like small or unhealthy spiders are actually just like skin bits from the larger spiders in the past. Oh, Tuco came over here to scratch at my leg. Trash can cam. Knee cam. Caps lock cam. Tuco, you just want the door open again? It's gonna be cold. Yeah, maybe I should move the heated blanket right next to the door. Do the air conditioner and furnace battling each other kind of thing. Tuco, you're so into that. Do you want the light on outside, honey? Does that help? Where is the focus? Don't know how much of this I can focus without actually seeing. There we go. I'm glad we have some unit tests for that read string function. That was certainly bugging me. Reload the continuous integration. Oh yeah, the tests are still passing. I could just watch all of Tuco's little motions all day. He's such a good little critter. Drink some of this transparent water. On. Oh, is Tuco back in the wheel? Tuco, you want help? You want a running buddy? Oh, fast. Too fast? Was that too fast? Oh, no? Wrong direction. Still cold. Is that enough? You want more? He's such a weird guy. Do you want more? No. Bonk. Oh, you want more? Which way? Which way? Show me which direction you want to go. Cat food word? Do you want more food? I think he wants the food. You wanted this? Yeah? Oh, Took. He seems to like these best if I leave all the packaging for him, including the foil. Got some large bugs here too. I think I got this from IKEA a long time ago. It's also covered in cat hair. I think this is supposed to be one of the giant sea isopods. It has like an opening for some reason too. I also hear that if you're in a really strange mood, it's possible to wear this as a hat. Just cat hair in the light. Are you leaving these everywhere? Yeah, Tuco does have some pretty interesting ears. He is so ears. So into that gravy. Oh, I feel like I should wrap this up and warm up a little bit. But thanks again for stopping by and hanging out with the rust coating. Code's all online, and the links are up on there. And I know I already said this, but thanks so much to all my patrons for keeping the lights on every month and helping with the expensive parts. Tuco loves just dragging that food everywhere and leaving tiny bits of meat all over the floor. Alright, well, I'll see you next time. Happy hacking, folks.